with the whole setup, I started by saying that I was looking for a killer app for blockchain. And this is really an effort towards finding and discovering where the gravity is for naturally decentralization to come. And this whole workshop is on AI, and I'm definitely interested in this. And towards this, I want to think about sort of two broad arenas. And on the consuming side, man, woman, child, everyone is part of this AI revolution. You want to consume it. Everyone wants to use it. All businesses want to use it. There's no question. It's an evolutionary technology. There's nothing, whatever you're doing, you just do better with AI. Huge impact, no question. And it's all aspects of human society, including perhaps, threat to all kinds of ways in which we organize ourselves. That's, I think, very clear. Everybody gets it. On the other side, perhaps a little bit less obvious is that AI technology is very accessible. You have, I have a high school kid, and Python has been part of his curriculum since middle school. So if you include data science to get started with AI, it's very, very accessible. And largely what I call shake and bake technology. And even at the cutting edge, you have libraries, you have access to cloud, shake and bake. It's pretty accessible. Not only that, so that's a large developer base. And the other aspect which the last several decades of technology has been winner take all. There's one search to rule them all. Social networks, the network effect. It's very hard to dismantle or disengage or take out things like WhatsApp, Instagram, and marketplaces. There's a network effect. They're all winner take all. And AI largely has so many applications, a myriad of them, perhaps not a winner take all. You put the two things together, there's a huge, on the left, you have all the developers. This is the supplier side of this marketplace. Very large possibility. If you include all college kids, high school kids, and just out of college, a very large number. 100 million is a very modest estimate out of what fraction of humanity can contribute to developing AI. On the right is the consumers, which is pretty much everybody, all businesses, all individuals. So very large. And this huge gravitational force on both sides are mediated through a very, very arcane, noisy, and a narrow set of centralized parties. And this is an academic setting, and I'm an academic myself, and we participate in these fora. So there's about 80 to 100 million individual repos, GitHub repos, total of about 400 million total, but individual repos like 100 million right there. And for what? You put it out open, and then you get, I guess, GitHub can give you stars, can give you downloads. Basically, they give you some metrics. And if you are an academic like me and several of us here, you can publish in AI conferences, and then perhaps you get a oral or a spotlight or citations. You get some noisy metrics for how you did, so that you can go put it on your CV and go all the way across on the other side and apply to just a few places to get a job. So huge gravitational force of all of human society on both sides being mediated by a pretty narrow, slim, and also noisy as intermediaries. The goal of this project, and at least what motivates me to get started, is this picture. I would like to alleviate this tension, and perhaps technology has a role in alleviating this this pressure on both sides of this funnel. Okay, that's the goal of this project, and this is the goal of, and it's a call to arms in a way. I'm inviting several of you to join this. And what I'll talk about is sort of the underlying technical, perhaps a technical underpinning for how to alleviate this pressure. If there are some decentralized aspects to it, very, very good. And we will see that, so maybe we should start with that. That's what I'm trying to get at. That's what this project is. So decentralized, I'm not sure where it comes, but I can definitely look at open, because that's perhaps a place to alleviate this pressure. So let's get started. So if you look at AI service, there are sort of two very clear models today. There is OpenAI, which is actually closed AI, where, no, I don't think they would want to change their name for sure. That wouldn't be a good name. So OpenAI, which is closed, and you have a few other parties like this. They offer AI services through an AI API access. You get, it's a paid portal. It works fine. I mean, there's nothing wrong with that as a service. It's a great business. The thing, though, is that it's not so composable. I mean, all the intelligence is within. It's a winner-take-all model again, just like in Google. Just keep that in mind. So there is some price to pay for that. On the other side, you have, especially led by Facebook, Meta, where you have open models. They are maybe just a few months behind the state of the art of the closed ones. And that like actually entirely open in the sense that they're freely given away. No obvious monetization. There's definitely none for anyone. And but huge flexibility for downstream use. And the societal pressures are so large that despite the monetization, lack of monetization availability, Hugging Face will be a platform for all this energy. So let's take a look at what parts are open and what parts perhaps I don't really mind being centralized or not as much. So if I look at, so I think of AI flow, I mean open AI flow, actually open AI. Well, data should be diverse. You get it from a variety of people, agents, just diversity of opinion. So you definitely want some diversity. That you want it to be open. Permissionless access. Open and permissionless go together. Training is hard enough in a centralized way, hosting and inference. I'm perhaps okay. Let it be managed in a centralized way. It's hard enough today in today's world. But there are two other aspects which are, first one of them is, I already alluded to, which is monetization. You do want monetization to be open, but yet monetizable. And in this previous dichotomy, I said this was monetizable by very definition, but not open. This was open, but there was really no way to monetize. And so I do want to look at monetization. And there's another aspect which is a little bit deeper and maybe subtler than monetization. I call this loyalty. Loyalty refers to the fact that you can't put monetization means economic number. You put a value on a certain transaction. And loyalty refers to ethical, safety, social, communal values. You can't really put a number on it. And if you can solve loyalty and make sure it's open and loyal, then monetization is a part of it. So three keywords: open. So let's look at monetization. So you want to share the model openly. This is a property that I want to do. So I'm looking at those technical primitives or what will alleviate that pressure, right? So you'd like to keep it open so people can participate. Permissionless, that's a keyword. But if you do permissionless, I do want monetization. Otherwise, how will people participate? I mean, it's not a scalable or in any way equitable system. So you want to share it, but the owner should be able to track usage and benefit from it. Kind of this has echoes of something of a revolution that software engineering went through decades in the past, where you want to share it, licensing it, but not really open there. I mean, here I do want to make it open. Unlike, let's say, Microsoft Word, which will give you a .exe and then you run it with some license. They tried this decades ago and they continue to. Here, AI model, I would like to be, it's composable. It's not winner take all. It's not a built product. And I want it to be open. So it has some flavor of licensing. Loyalty, as I pointed out, is a bit more. Here, you can't put an economic value on it. And I want to sort of decouple. So from societal and ethical and safety values from actual AI development. The AI is what it is. It's developed openly, but the owner or the community or an individual or a group that developed it gets to decide their view on what and when and how you would like to use it, or it can be used. There can be I don't know, woke California model or a red Texan or a blue Austin model. I mean, they get to do. It's there's nothing preventing no one on that. So diversity, in other words. The diversity of how we as humans live, AI can live too. And if you have an open model that's given away, yet be loyal, then we are looking good. So those are the three keywords here that I think would alleviate this pressure. Open, permissionless usage, so people can participate easily. And most of all, not just participate, but also use existing artifacts and fine-tune them, develop them, and improve them. So open is good. Monetizable, you want to have an entrepreneurship, it should be scalable, you want to make a living of it. And finally, not just for the money, but also have some values around it, loyalty. And I put them together, I call this OML. So you have a model, could be .py, Python, safetyf, .onnx. You hit a button, maybe it becomes .oml. That would be a start. You can download an OML file. It would perhaps look like if it was originally a TF, TensorFlow, it now also is still open. You can look at all the weights, but it's .oml. So what would it take to build such a crypto primitive is largely the call to arms that I'm talking about. So OML is sort of a new cryptographic primitive. One way to look at it from a cryptographic lens is to look at sort of classical other cryptographic primitives and ask how .oml may relate. One way to think of .oml is something as a special case of program obfuscation, one of the grand challenges of all of cryptography. In fact, it's crypto complete. If you can solve indistinguishability obfuscation, then you get a whole bunch of crypto primitives, including .oml. But that's not anywhere really practical yet. And even the theoretical understanding of when I/O is doable for what kind of computations is still an open thing. And I want to propose and promulgate one particular line of attack at this .oml here. And this one has to do with the fact that instead of taking on any software program and making it open and yet monetizable and loyal, I want to look at a relatively limited class of programs, especially those that involve AI models. In particular, perhaps language, those that include human language, natural language. So if I think of how cryptography was developed, actually, if I look back all the way back to 1950s when cryptography was born, and before that, science fiction was built around cryptography and hiding using natural language already. In other words, semantics is where you did the hiding, and ciphers and codes exist from a long time past. But of course, that's not how cryptography evolved or the digital world we evolved in, communication, compression, everything became digital. That means you convert all information into bits. And once they are zeros and ones, the semantics went away. Semantics are to be interpreted at an application layer. All the underlying pipes, including cryptography, all of them manage just the bits. Every bit is equally important. One bit off is completely off, and you want to get it exactly right. So every bit critical. But the AI models that I was alluding to are not quite like this in three ways, at least three ways. First, there's an analog aspect to it. They have real numbers. I mean, there's a more significant, you can quantize it. Like I said, .tf, right? There's obviously it's also still digital, but there's a more significant bit, least significant bit. There's an analog aspect to it. In other words, it's continuous. There's some embeddings. Second, there's an overall geometry around it too. So it's not just individual continuous numbers. There's a low rank, and the AI models and processing on them heavily use this geometry. Finally, I don't need to necessarily protect it exactly to the bit. If you get it approximately, you hide it, you open it, but you're approximately loyal, approximately monetizable is okay. And even that approximation is not just on an instance by instance basis, on average is also okay. If once in a while some prompt goes through my open model without being accounted for monetizable, I'd probably be okay with it, as long as a large fraction of the time the usage is tracked. So there's some slack, in other words, a slack that a pure cryptographic approach doesn't quite capture. And one particular method is to use this slack and devise methods. Since we're talking of AI methods, you use AI itself to devise these methods to create .oml. There's some precedent to this already. And I'm an information theorist. I work on codes, I work on communication, and there's a precedent there too. Communication is done in analog. The real world is analog, but communication is all done through bits. So coding is all done from bits to bits, but you have to go back to the real world. So you call that modulation, and come down back to bits. And that was how we thought we will do, and that's the only way codes were known to be built that are sort of reliable. And using AI methods, one can work directly. We've been seeing in my own research program and others that one can use AI to directly work at the analog space, because that's what you really want already. And this kind of a thinking that one can build, especially for .oml, this cryptographic primitive, to use AI methods to protect AI models is something that we've been trying as part of this program. We have an event, so I would like to give a shout out. I'm organizing sort of a workshop to explore this thread. It's on Thursday, right after SBC ends. It's also just a few minutes walk from Columbia University, at Columbia University. So this is a good place to sort of sign up for that. I want to thank all the collaborators here with whom I've chatted and discussed this at length, especially my thanks to Sandeep Nailwal for first formulating OML at a dinner table at his house. My close collaborators for a long time, Himanshu Tyagi, he's a professor at the University of Science. Sevung Oh is a professor at the University of Washington, Seattle. And Andrew Miller is here, professor and my former colleague at Illinois. And Andrew has been telling us that there's one way to solve .oml, and he'll talk about it at length. I should let him speak. There's a very obvious way to do .oml, which is why not use trusted hardware to run the whole thing? Then it's open, it's downloadable, but it's run in a hardware enclave, so you can't take it out. And of course, you can track it, it will be loyal, everything you want. And several of my students, Nyusha, Oleg, Zeroi are my students at Princeton, graduated, some of them. And Anshul and John are students at University of Washington. Thank you. Yeah, the question is, let's go back here. So Shankar is asking a question. He's saying, why does loyalty matter? And in fact, one of the reasons I already distinguished monetization from loyalty is to precisely make this separation. Monetization helps just make sure economically viable. So I think you're buying into that. That's, it's good, transactional, it's very good. But you do hear, right, that AI can be a societal threat, civilizational threat, some would say. And all of that has to do with safe usage. And one of the reasons, you may also have heard that Gemini was in the doghouse because, I don't know, there was some controversy, some particular prompt, they did something wrong. It's a mess. To do AI models are hard enough that generalize globally, scale so well. And on top of it, you have communal values, which can differ, which even reasonable people can disagree on. So you really want to decouple. And one of the side agendas I have through this .oml primitive is to decouple these two core topics. The AI developers and development can happen at scale in its way, and the communal values should be decoupled from so usage is decoupled from development, in other words. And this is, all of these is towards, is to get to this kind of a flat, is to get to this sort of flat thing rather than very high pressure on this narrow funnel. Yeah, the question is, can you use cryptography to do OML? I'm glad people are already buying OM and L. So that's good. I'm already happy with that. Any other solution, I'm all open. In fact, I don't think there is only one OML. That's why we wanted to have a whole session discussing. There'll be many approaches to do OML. It depends on the security models. I mentioned already the hardware method, which is a kind of a different way. And someone else has the key to it. Perhaps Intel has the key, or NVIDIA, the hardware manufacturer has the key. So I would not think that there is a way to solve .oml. Just like I said, AI as a technology is not winner take all. I think, where did I said that somewhere here. AI as a technology is not winner take all. I don't think OML is a winner take all either. In fact, one of the goals of that Thursday symposium is to really explore different angles in which one can view OML and different approaches. If there are encryption-based methods and they work well, and maybe for some applications, more power.
Fantastic. Thank you so much, Pramod. And yeah, please consider joining the event of OpenAGI.
It's easy to sign up, so I'll just show them maybe the...
Yep, there's the last slide here.
Yeah, so I'll just do that, yeah.
OpenAGI.xyz symposium.
Yeah.
Thank you. So our second speaker today is Dominique Clemente, research engineer at the WorldCoin Foundation. So yeah, thank you very much for coming on stage. And
thank you. All right. So I guess if I just go next, it should be next one. All right. Cool. So I was introduced as Dominic, but like my pseudonym on the internet is DC Builder. It's like a crypto thing where people have different names. But anyway, so I'm a research engineer at the WorldCoin Foundation, where we mostly work on building the future of privacy-preserving proof personhood. So I don't know if you saw in front of the building or like at the beginning, we have like 2 orbs where we're building sort of like a way of how to prove that you're a unique person online and on the internet. And within there, I work as a research engineer on the WorldCoin Foundation team, where I mostly work on giving grants to different people to solve different sort of problems within the ecosystem, be that cryptography, be that protocol design, and other things. The reason why I'm here today is because a lot of my interests intersect within like cryptography and AI and digital identity. And I feel like I have a different view than most people. I feel like I'm the only person and the speaker set that doesn't have a degree. But yeah, within industry, I've seen a lot of things. And I'm also an active angel investor in this space. And so I wanted to sort of show what sort of things I see in the decentralized AI ecosystem and what sort of players are doing, what sort of open problems are there. So first of all, I would like to just put a quick disclaimer that views are my own. Shout out to all the lawyers in the world. So yeah, why you should care about decentralized AI? So for me, in the crypto space in general, everyone cares about sort of aligning incentives. Everyone cares about self-sovereignty. In the AI space, I think people have seen that now that AI agents have become very powerful, they sort of get pushed to a very adversarial model where people are competing against each other, and people now start to think about sort of alignment or coordination and cooperation. And since they've discovered this very adversarial environment, they sort of need to start using things that we've been building in the crypto space for sort of aligning and cooperation to sort of align incentives among participants and design mechanisms that are fair for everyone. And I think that the technologies that we've been building over in the crypto space for the last 10 years are very relevant today. So as you've seen, like a lot of centralizing forces that happen in AI, like leads to centralized data, lead to centralized compute. When you centralize data and compute, you hinder innovation. You start to have politics as opposed to open innovation and benefiting humanity. And users usually are at the short end of the spectrum, where they always are the ones that are getting the value extracted out of them. And then they sort of are unable to own their data. They have to sell their data to get access to services, et cetera, et cetera. Another problem is that if companies building AI or protocols, projects are centralized and really depend on sort of decentralizing forces, you as the user sort of cannot really trust them, because their incentives are not to benefit you. They're not to benefit a set of values or common mission. They're usually set to benefit the vision of like, how do I make money, or how do I sort of able to have shareholder value or create products that people want to use. As I mentioned before, open access equals open innovation. So if we have, like we've seen this many times, right? Like Linux is the thing that runs 98% of the servers, right? Like React is the framework that runs most websites or most people code in. PyTorch is the most used framework, is open source. Like all of these things, like if you have something that is open, people can use it, can tweak it, can publish new papers, research, and benefits everyone. Another thing that decentralized AI gives you in a lot of different ways, mostly using cryptography, is privacy. I feel like the AI space does not necessarily care that much about privacy because it hinders user experience and it disallows a lot of potential use cases. But we're getting to a point where a lot of these things start becoming useful. And something that I feel is also really important is that currently everyone is working within their own little like ecosystem, but I've seen very few like cross organizational collaboration, right? We've not seen a lot of like global coordination from multiple entities. Is more like disjunct research, disjunct products that are not interoperable by the nature of how these sort of services work nowadays. So things that I've broadly seen, not just from the maybe like the speaker lineup, but from like the entire industry that starts to play at the interplay of AI and crypto, are things like data and compute marketplaces, right? Like if I have some data, how do I make sure that I can get rewarded for that data? Or how do I sort of access compute outside of compute clusters that are like provided by AWS or other compute centers, right? We've seen a lot of startups that have emerged in this space. So there's a bunch of them in the crypto space. So one of them is, for example, Prime Intellect, which is trying to like allow you to decentralize compute and get access to compute from lots of different places, and people can provide compute and consume compute, and they can run sort of auctions that are transparent for this compute, as opposed to me having to have sort of some private relationship with companies that manufacture hardware so that I can get the H100s before everyone else. And it's like always like a race to the bottom in politics, where if I want to get 100,000 H100s, when I have to compete with other top companies, but maybe I cannot do my research. Other sort of sets that I've seen is, okay, thank you, training and inference networks. So we've seen that training is something that is extremely resource intensive. Like if you want to train a trillion parameter model, you really require like hundreds of thousands of GPUs co-located in one data center for many months, and then you release a new foundational model. I think that this model sort of works, but I would like to move to a future where we are able to sort of provide compute in a sort of decentralized and collaborative way, where people can then sort of train things together. And there's all sorts of new papers like DeLoco, for example, from DeepMind, I believe. And there's like open DeLoco versions of it, like allows you to collaboratively train models in the network. Same for inference, right? Like instead of me having to trust an API, I can just like send a compute job or compute AI task to an inference network, and then they can give me the result. And it may be a proof, a computational proof that they're giving me the right result applied from the right model. Decentralized AI is also really good for verifiability and provenance. So cryptographic primitives like zero knowledge cryptography, MPC, fully homomorphic encryption give you a lot of sort of accountability for what the computations that you're providing to users. Right now, all the sort of accountability is enforced legally. Like a company is not able to provide you a model that you've paid for, or like a model that you didn't pay for example, to sort of pocket. Like if I query, I don't know, like Claude 3, they cannot serve me Claude 2 because otherwise it would be illegal if I'm paying for Claude 3. But they can, for example, provide proofs, like computational proofs that they've actually provided me the right result. Other things that I've seen are agents and agent networks, agent hubs. So we've seen that as within crypto, for example, there's a lot of like on-chain primitives that exist, whether it's financial or others. A lot of these are people experimenting with different agents of like, how do I sort of solve different problems and provide a smart agent that's able to interact with the system to become self-sufficient. And privacy, right? So we have all sorts of different types of people building privacy solutions as well. And one of the things that I feel like it's also really important is hardware, right? Like you have companies like the Tiny Company is trying to build tiny computers to sort of distribute to people to have access to petaflops of compute. But it's a problem that is really, really hard. So where we're now, I feel like in crypto, we have a lot of interesting primitives that are really important to coordinate people at various different scales, be that economic, because right now I feel like most of the bottlenecks are economic for decentralized AI to be feasible. So we have in the crypto space, we have a lot of mechanism designers like financial incentives and innovations of how to coordinate different parties and align incentives between them so that they perform the right task and we don't have to sort of trust them for their word or have some way of legally enforcing those rule sets. Programmable cryptography, as zero knowledge cryptography and other things are very feasible nowadays. And there's newer inventions like multidimensional resource pricing. So if I have a GPU, I have a CPU, I can price them separately in a decentralized network that might have different configurations, pricing for those things. There's a sense of urgency or innovation. And finally, we have a lot of capable teams getting funded, both in the cryptography space and blockchain space, as well as the AI space and the intersection thereof. So one of the biggest problems that I see at the moment is that there's no big shelling point for the centralized AI. All of the products and services that we use come from centralized people or agents or institutions, companies, and there's no really big push for decentralized AI. We lack sustainable economics and incentives. There's no that much robust infrastructure that we can use in the decentralized setting. All the decentralized sort of systems are not comparatively like as good as the centralized one, mostly because it's like a harder computer science problem and uptime problem. Privacy is not the norm and always comes at a cost, right? So if I want privacy right now, it comes at a cost of like maybe a worse model that I have to run client side. And designing reliable systems and agents is hard. So who's building it? The team's here, lots of others, and hopefully you in the future. So for me, like there's a lot of other thoughts that I would like to share, but since there's only 10 minutes, if anybody else wants to chat to me after, feel free to ping me. And thank you very much for listening.
Thank you. Any questions? We have time for a question. Yes, over there.
Yeah. So privacy here, for example, like if I want to create a zero-knowledge proof about some inference or something, the computational overhead of creating a zero-knowledge proof is like 100 to 1,000 to 10,000x, depending on what proof you're creating. So the problem here is economic, right? Like me just running an LLM inference is already expensive. Like one token, like 1 million tokens, like I don't know, like $6 or something. If you want to create like 1 million tokens in a privacy preserving manner, well, it's like $7 times 1,000, right? So like what sort of use cases make privacy feasible and economic? This is sort of like the open problem that I see, right? Like people want privacy and people care about privacy, but not enough to pay $7,000 for it. If you're the average user, you care about like consistency, you care about accessibility, and you care about like just lack of friction when you're using products that leverage AI. So this is sort of like an open problem. Apple Intelligence is doing it in the way where they have like attested servers that sort of allow you to attest to something running correctly, and they timestamp things, and you can get some cryptographic trace of how things executed in a backend server without revealing your data. But then it's like a TE, or like trusted execution environment problem, where it's a different sort of set of trade-offs. Yeah.
Thank you so much.
Thank you.
Very good. Our next speaker is Roxy Jia, a new assistant professor at Virginia Tech. So thank you so much. The floor is yours.
Okay, thank you for the introduction. All right. So today I'm going to talk to you about fair data attribution at scale. So this talk is going to be about how we can evaluate data contributions in large-scale machine learning models. So let's start by defining data attribution. It is a process of quantifying the contribution of individual data sources to model performance or behavior. Imagine that you have a training data set comprising different data sources, and after training, you want to understand the impact of each data source. You can apply data attribution in two ways. One is to evaluate contributions to some aggregate performance measure, evaluate on a test set, say 0.9 accuracy, or you can evaluate the contribution with respect to a specific model output. So why is this important? I will argue that it is fundamental to responsible decentralized intelligence, echoing the theme of this summit. So why is this? Firstly, data attribution allows us to track the impact of how different data sources affect model output, providing transparency, which is a crucial component for responsible AI practices. Secondly, it allows us to fairly compensate data contributors in decentralized AI platforms. And thirdly, it improves the performance by helping us identify high quality and low quality data sources, which is useful for building intelligent systems. So the question is how to fairly determine and attribute value of data. Well, this is a very tricky question, especially different data contributors might have different mind about what is fair. To address this question, we turn to game theory and a concept called the Shapley value, which was invented by a Nobel Prize winning economist Lloyd Shapley in 1950s. So what is Shapley value? You can imagine machine learning as a team sport, and each data contributor is a player. Together they form a team. So Shapley value is a principled way for you to credit each player for the team's success. The Shapley value has three properties that makes it special. The first one, it ensures a full value distribution. So if you sum up all the Shapley values for different data contributors, you get the total model improvement by training on the entire data set. So this effectively aligns the incentives of different data contributors to improving the model performance. Secondly, it is actually based on the contributions. So if two data sources have equal contributions, they get the same value. If you don't make any contribution, you get 0 value. So this ensures fairness and prevents from gaming the system with useless data. And lastly, it has a property of additive decomposition. What it means is that if your data can be used for multiple times, you can calculate the Shapley value for each and sum them up. So this is very useful because it means that the more you use your data, the more value you will accumulate. So here is the important bit. The Shapley value is unique in satisfying these 3 properties that people find reasonable. So that's really important because it eliminates any ambiguity about how to define the data contribution and provides a principled way for us to talk about data value. So here is how you can calculate Shapley value. So imagine that we have a training set of 3 data points, and you want to calculate the last fish here. So what you can do is that you look at the other 2 data points and consider every possible subset of these 2 data points. You have empty set, you have a dog, a cat, and dog, fish, cat together. And for each subset, you ask the question, how much your model will improve if you add a fish into that subset. Maybe 30% for the empty set, 30% for the dog, and so on and so forth. So the Shapley value is effectively the average of all these improvements. Effectively, you essentially calculate the value for every possible scenario and comprehensively evaluating the contribution of this fish. So that's how the Shapley value is calculated. You might have already realized that Shapley value calculation is incredibly demanding. So in fact, I'm sorry that all these animations and format is messed up. So in fact, there is a long line of existing work that is trying to treat the theoretical properties with computation efficiency. So you may use some other notions that do not have this uniqueness guarantees, or calculating Shapley value with some alternative, multiple simpler models. But now you have a different problem. You have competing notions for data value without clear guidelines. So this is especially problematic in decentralized AI system, because if you think about the decentralized data marketplace, you need a single trusted method for valuing your data. It's like you cannot have different competing notions for what is the worth of the dollar. So you really need to have some theoretical guarantees and uniqueness in terms of when we talk about data value. So that's our goal here. We try to bridge the theory and practice and try to find some data value that is theoretically sound and at the same time practical to compute. So that's our solution, which we call in-round data Shapley. It is theoretically principled to satisfy all Shapley value axioms, fairness. It is also highly scalable. It introduces minimum overhead into your regular training processes. And I want to emphasize that it is also very flexible in the sense that you can apply it to different styles of learning as long as the learning is done by gradient descent. So here is the idea. So it's all about divide and conquer. Instead of dealing with this super complex training process, we decompose it into individual gradient updates. Remember the additive decomposition property that I mentioned earlier? It lets us focus on individual gradient update and calculate the value of data and then sum them up. So what's interesting is that for each gradient update, the change of model performance is very tiny. It is so tiny that it can be well approximated by some additive function. And for additive function, the Shapley value can be computed with constant time for each data point. So that's our secret sauce. So with this efficient algorithm, for the very first time, we are able to rigorously calculate the value of data for some really large scale machine learning training. So also we can actually track how the value changes during the time of training. So here, let me walk you through some findings from our study. So first we look at how the value changes as we to generate some specific type of content, say math related content. So what's interesting here is that, so where is my animation? So maybe I will just summarize with the takeaway. So what we found is that the general corpora have most in the beginning of training because it helps with learning some like basic features of language. And then in the later stage of the training, the task relevant corpora, for example, archive, will be more useful for like learning generating math-related content. And so we also look at how the value distributes when to generate different types of outputs. For example, let's say we want to generate some output that is very similar and even a paraphrase of some original training data. So as you can imagine, the value of the original training data will top if you try to calculate the value distribution for generating this particular output. So here is what's more interesting. So we look at the value distribution for creative generation. So let's say we want to generate some story about a musician. So what's interesting is that here a Wikipedia page about some Malaysian pop band, which is not directly related to the story that we generate, pops up to have very high value. We are talking about 99.95% high valuable. So this really provides some new insights. So when people talk about like training AI with people's data, it's fair use because output is different from input. So this study really shows you that even if the output is seemingly original, the training data still plays a huge role. And also, let me check. So this really introduced some new perspectives for the ongoing debate about fair use and copyright in AI. So lastly, we look at how we can utilize this value to improve our data quality. What we do is that we remove those data points with negative value. So as a result, you can get a better performance and faster training. And here is an example of the negative value data. It's a bunch of meaningless symbols. And what's interesting is that we found this bad data in a very supposedly well-curated corpus, the PILCC. So the takeaway here is that there is really a long way to go for data curation. Even this supposedly very clean data still have a large portion of bad data that hampers the efficiency of learning. So with that, I introduce you to a new solution to talk about data value. And also it gave us some pushes of frontiers for talking about model efficiency, model performance, as well as some compass landscape for ethical and responsible model training and development. So with that, I would thank you for your attention, and I'd love to take some questions if there is a time.
Thank you very much. We have time for one short question with microphone.
First of all, really interesting research. I'm curious, how do you pick the score function during training? Is it just the loss function, or is it similar to like computing the Shapley post-training where you have like a model evaluation metric like F-stat or something like that?
Mm-hmm. Yeah, that's a great question. So in our study, we look at the training loss. You can also look at the loss of generating some validation data. So the loss is cross entropy. But in principle, like the methodology that I described here will apply to any like differentiable transformation of cross entropy loss. So imagine that you are evaluating, maybe the confidence of generating some output. It should also be work as long as it's a differentiable transformation of the cross entropy loss. We need differentiability because we want to use this gradient to approximate. Remember, I said like we use some additive functions to approximate the original function, which is hard to calculate the Shapley value. And that additive function requires us to calculate the gradient. So as long as you can calculate gradient, you will be fine to use this framework.
Gotcha. Thank you.
Thank you.
Roxy, thank you so much for your time today. So our next speaker is Tandus Ree. He's an incoming assistant professor at, she's an incoming assistant professor at Penn State University. Thank you very much and looking forward to your talk.
Works. Okay, thank you. Well, I'm Tanushree Sharma, and I just started a new role as assistant professor at Penn State, and I work on human factors, security, privacy, and governance. And today, this work that I will present focuses on developing method and tools for governing LLM outputs based on people's value. And for better contextualization, I'll talk about LLM output on particle content, one of many sensitive use cases we explored within this inclusive AI tool. And in this talk, I'll more emphasize on the method than the results. Okay, So to start with, multimodal LLM, which involves generating output from various data types simultaneously. So imagine a model interpreting a video. So it needs to analyze the images, closed caption, and audio all at once. And now think about how complex this can get with sensitive topic like video of a US presidential debate. Because in this case, these models need to understand and interpret emotion, facial expression, and different ideologies. And to handle this kind of multimodal input, there's need of human intelligence or cognitions and contextual understanding. And here's an example of ChatGPT's response to this US presidential debate, a clip from 2020. And generally, it focuses more on content discussed in the videos rather than the context of the situation itself. And another thing that's interesting here, that it tends to overemphasize one speaker over the others. And given the sensitivity of this topic, such interpretation could be controversial. So, current literatures on LLMs suggest having neutral or unbiased responses. But what does it mean by unbiased response really? So it would not be clear enough unless we involve users and subject matter experts to build a baseline understanding and potential metrics along the way. And to address that, we ran a threefold study involving both experts and the users. And the first fold involved media scholars and journalists who have expertise on handling multiple data sources for their news and media reporting. And what we got from there is the baseline human output of these video interpretations from this expert and their judgment on LLM's outputs of the same video. And according to the expert, fact-checking, positionality, and the level of selective exposure and the comprehension by the audience are some of the main factors for such interpretations. And these factors of comprehension by targeted audience lead us to the second fold of this study. And this second fold involves building exploratory metrics based on users' deliberation on LLM outputs on the same political video. And it turns out that these users as a group, they value both subjectivity and objectivity of these video interpretations. And in case of subjectivity, they value more about the interpretations of speakers' emotions, both from the visuals and audio interpretations. And objectively, they prioritize accuracy of this content discussed in the US presidential debate. However, in the individual deliberations, objectivity takes the front seat with fact-checking and balancing multiple political ideologies being the key consideration. And the third fold is about, how do we engage this different group of people to deliberate at scale and make this decision in a democratic manner. And today already we got to know reasonably a lot of definition about democratizing AI from the speakers earlier. And one of such definition I would like to mention here from two of the organizations, one is NSF and OpenAI. They put through that, the definition is to decide what rules and policy AI system should follow within the bounds defined by the law and diverse perspective of public interest. So our questions was, how do we design such a democratic decision-making process for LLM outputs? And I will go very briefly here because I don't have time to cover everything. And that's where the framework from DAOs comes in, DAO as in decentralized autonomous organizations, where there is no centralized party that dictates the decision-making process. Instead, the community deliberate on a specific topic on forums and make decisions through voting on certain topics. So we apply this DAO framework in LLM context, and then we engage both expert and users to deliberate and refine a proposal on how LLM should be designed for future improvement for video interpretation on particular topic. And another layer of abstraction is that how do we determine about suitable democratic government method for LLM context? So we designed several experimental systems with ranking, weighted and quadratic voting method, and allowing users to assign their preference for different options of LLM model development. And this helped us to understand which governance method users perceive as more democratic. Now the question is, how do we measure which one is suitable? And one way is through the user satisfactions and their perceived quality of this process being democratic. So we adapted the variety of democracy, which is a very popular metric in the political science, to assess the country level democracy based on citizen satisfactions. And our findings show that the user generally perceive the deliberation and decision-making process being inclusive and democratic. Notably, in the quadratic voting method, users purported to have a higher degree of democratic than the other voting system that was there. And finally, before I wrap up, some open question I would like to leave for thoughts. So if we are to implement such a democratic process for end user tool with popular LLM applications, then how do we ensure the diverse and unique voices that are included? There is no bad actor or bot responses there. And how do we sustain this process and keep engaging users for making decisions and value-based LLM outputs on controversial topics? And lastly, you can find more about this project on this OpenAI blog and some of the research papers in this QR code. Thank you so much.
Thank you so much. Apologies for the time. I was told we don't have time for more questions, but yeah, please do check out the blog, as Tanushree mentioned. Our next speaker is Ian Mears. He will be speaking about a Waterlog. What is a Waterlog? Please enlighten us.
Good you ask. Yeah, so hi everyone. My name's Ian Myers. I'm a professor at the University of Maryland. This was originally supposed to be a talk on ZK machine learning plus, zero knowledge proofs plus machine learning. My work originally pioneered how do you use ZK snarks for applied cryptographic protocols on a blockchain. It's the kind of stuff that underpins Zcash, Railgun, Aztec, Tornado Cash. The real idea there was if you have a consensus protocol and consensus on the state of the world, you can prove something about it efficiently, and actually that turns out to be commercially viable. So the idea is, well, can we use a blockchain and machine learning to do that? I'm not quite sure that's there yet. So I wanted to talk about something a little different, more so on the how do we use consensus side of this. And so this is joint work with my colleagues at Johns Hopkins on what we call a waterlog for large language models. The goal here is, if you're familiar with watermarks, goal here is that you want to identify the output of an LLM, say if you've got someone accused of plagiarizing something in your class, or you know, a deep fake or something that's in the news, right? And so this has been a lot of work on this. I had a paper at ICML last year looking at exactly how do you tag these kind of things, right? So you have some output that came from, say, ChatGPT, and you want to verify that it came from there, and you want a way to track it. So the idea in a watermark is you are going to perturb the outputs of your LLM just slightly in a way that you can later recognize it. And so this is nice, it's efficient, it's resilient against things like truncation through a couple of cool tricks. And there's been a lot of interest in watermarks. They ended up in the Biden executive order on trustworthy and safe AI, some long bureaucratic name like that. But they have a couple of downsides. First of all, you have to trust the LLM provider, right? Not just to put the watermark in, that's kind of fundamental. You have to trust them when they answer, hey, did this come from you or not? So you could imagine, like, if Elon Musk, say, had a large language model, he might be inclined to accuse somebody of plagiarism when they didn't, or maybe cover for his friends if they did, right? You can equivocate. That's bad. You also can't embed metadata in these watermarks very easily. I'll get to that in a moment on some caveats. So you can't track like what the prompt was, who did it, any kind of background on this stuff. All you get in this system is a yes, no of whether it's yours or not. And lastly, they're not very robust to paraphrasing. So they're not perfect. And there's been a sort of Cambrian explosion of better watermarks since we had this paper. Some of them are quite good, but they all go in similar directions. One of the interesting ones, if you want verifiability, is to do asymmetric watermarks. So the goal there is very similar, and the tricks are sort of the same, right? We're going to embed some bits in the output. But instead of embedding a couple of bits as a signal, we're going to embed a public key for a cryptographic signature scheme, and then we're going to sign the output. So this has some advantages. It is verifiable. You can check as a third party just by verifying the signature. The downside is it's basically only a theoretical interest because you need a lot of bits to encode a public key. And that means you have to perturb a lot of the outputs. And so running this on a practical model, well, it takes like 200 seconds for 1.5 billion parameters. That's not going to work as you scale it up. And it also still does not let you have metadata, right? Because all you have here is a signature. And so neither of these things are quite good. And depending on your threat model, operator can still frame people here. They can still like potentially surreptitiously insert data into their system and say, this was the output of a model, even if it wasn't. And these are all properties that we would like to fix. So what do you do about that? Well, the solution is a blockchain. Well, not quite, actually. It's a transparency log of some sort. And this approach that we came up with, which we're calling a waterlog instead of a watermark, is that you log things in some form of transparency log. And if you do this, you get metadata, non-repudiation, unframmability, and federation. And it turns out to actually be, in some cases, better than a watermark. And so the idea here, for those of you who are familiar with blockchains, is you use something like a Merkle tree or a transparency log. And therefore, you can verify being insert entries into a data store, and you can verify that they're in there. You also get things like timestamping on this. So the model here is that you have a bunch of different LLM providers who can log their contents with a third party. They're trusted to do the log, but they are not trusted afterwards to answer honestly over whether something was in there or not. And so we built a proof of concept version of this. This is so proof of concept that I didn't want to put the name of the system up here because the students want to call it Dredge, and I don't quite like that. So that may get changed in the paper when we put it up. But the proof of concept version of this is a transparency log and a verifiable audit mechanism for the log. And the details will be in the paper. But when you actually build this, it ends up being surprisingly practical, at least under the cases that my grad students have cherry picked to use here. But it turns out to be pretty robust against misspellings and paraphrasings. And the reason for this is that underneath here is an embedding, right? So we first compute an embedding of the thing and then a SIM hash, and then we store that in the log. And so that gives you a different set of trade-offs than a traditional watermark, right? Because it's more robust to paraphrasing. It is, on the other hand, slightly less robust to truncation. So there's some trade-offs here. But I'm really sort of interested in this approach conceptually and to see what other people can do when they run with it, because it seems to fundamentally offer a different set of trade-offs that I'd like to explore more. This paper should be up online in the next 2 or 3 weeks, but it is not up now. So thank you.
Thank you very much. I don't think we have time for questions. Really sorry about that. The last talk of the session is about ZKML. So we've become more and more ZK, and now it's ZKML. So yeah, thank you so much. Tiancheng, you're CTO at Polyhedra Network. The floor is yours. Thank you.
Thank you so much. And I think here. So I'm Tiancheng from Polyhedra Network, and I'm co-founder of Polyhedra Network. So today I'm going to talk about some ideas, some insights about ZKML when we're doing the research there. No, it's not working. Which one? Oh, this is this one. Okay, so currently, well, main bottleneck of like doing machine learning is like the computation, right? Number of H100 is quite limited, and you cannot get with a fairly cheap price. So, well, the problem even for ZKML is even more intense because, as many people think, the machine the ZK is quite a big overhead here, and it's about 1,000 to more than 10,000 times overhead in zero-knowledge proof compared to native computation. Well, but here we managed to get some insights to this machine learning problem. And here's a primer problem where it's pretty straightforward. You are given 3 matrices, and you want to verify the computation of this matrix multiplication, which is quite commonly used in machine learning and it's inferencing. So yeah, I'll give you like 20 seconds to think about this problem. So a naive solution would be you multiply this 2 matrix by your CPU by yourself and check it whether equal to C. But this is too expensive. This is way too expensive to do it in a circuit, in a zero-knowledge proof circuit. What we do is we do the following. Instead of directly do the multiplication, which takes n cubed time, we multiply it with a random vector first. And this random vector is getting multiplied with A first, which takes n square time. And it will outputting another random vector, which get multiplied with B. Again, it takes n square time. And for the right-hand side, it's a random vector multiplied with C, which takes n square time. So overall, it's actually n squared, not n cubed. And the similar observation can be found in convolutions and other stuffs. So as you can see, to verify this zero-knowledge proof computation, so to verify this computation in ZK circuit, you don't need to have the verification circuit as big as the computation itself, and it can be way smaller. So we are doing a lot of experiments here, and we implemented a similar mechanism for convolution. As you can see, the original computation is like way bigger than the number of constraints. So the number of constraints is like 100 times smaller, and we are doing stuff for the remaining. It's work in progress. We are doing stuff for remaining operations. Yeah. So we are looking forward to have an even more aggressive future. Like ZKML can be even faster than inferencing itself. Yeah. So currently, what's current status is you can do large language model in ZK, where it takes like more than 10 minutes to get 1 token. But I'm thinking like we are doing a work that is actually making machine learning private. There is no overhead for that. We are envisioning that future. So, and at the same time, we build a state-of-the-art proof system which brings the overhead of doing ZK from like 10,000 to several hundred. So it's still way faster, and as you can see, the number of constraints is like 100 times smaller than number of computations. So I think we can match in the future the number of the time for the ZK computation is where we can match the inference itself. So we don't need to pay a lot of overhead to the ZKML. Yeah, I think that's it. That's about. Yeah, thanks.
Thank you very much. Thank you very much, Cheng Cheng. Sorry, we don't have time for questions, but I'm giving over to the next session. Thank you, everyone.
Okay, now we are in the most interesting session, research spotlight. And our first speaker, Lilia Tang, PhD student from UIUC. Let's welcome Lilia Tang.
Hello, I'm Lilia, and today I'll be talking about implementing high-performance zero-knowledge ML provers. This work is done by me and my colleagues at UIUC. An increasingly important problem when using machine learning services is the lack of transparency in how our data is being used. Models are appearing everywhere now, from chatbots to medical devices, and a necessary step in improving the transparency when using these services is being able to verify that the ML model outputs are honestly computed, given the model architecture. One way to do this is through ZK snarks. A ZK snark is a cryptographic tool enabling a prover to prove that a statement is true to a verifier without disclosing additional information. For example, we can prove that a model is executed correctly without sharing its weights and inputs. One way developers can try this out is through using ZK snark frameworks. Developers can write a model function in the framework and compile a ZK circuit. Then the ZK framework can use that circuit to determine how to compute the proof given the input and also verify the proof. Now there are many ZK snark frameworks, but how do we pick which framework to use and how to use the framework effectively? So we designed a ZK snark proving benchmark ZK-perf to help compare different frameworks. And we designed two ML circuits. One is MNIST CNN and the other is DLRM to show the performance of convolutions and multi-layer perceptrons. And we implemented this over 4 frameworks. So this is the proving time for all tasks and frameworks. And one interesting thing we found was that NARC Groth 16 was fastest on crypto circuits, but slower on ML circuits. And Plunky 2 was faster on ML circuits. So why is this the case? One reason is lookups. So lookups can help avoid repeated computation by storing input and output mappings for an operation. So this is useful when it is expensive to compute the operation with just linear arithmetic constraints. So for example, the ReLU operation can be proven with bit decomposition or lookups. This is done by showing that the sum of the bits correspond to the original input and that each bit is 1 or 0. And the output is based on the value of the signed bit. However, we can also instead use lookups where we commit a table and then add some lookup constraints. And here we benchmark the performance of lookups over these 3 frameworks. And we found that GNARC's lookups are slow enough that bit decomposition is actually faster, and Honky 2's lookups are the most scalable. Another interesting optimization we investigated was with circuit structure. So for Halo 2 and Plunky 2, they have this concept of rows and columns. Rows affect the sizes of operations that are used in the prover, and these are padded to a power of 2. However, columns affect the number of operations. And one way that we manipulated the rows and columns was through the dot product gate. There are many matrix multiplications which occur in linear layers, and these can be designed to fill the size of the row. So if we have a 110 column configuration, we can fit 52 dot product operations, and then the result is 5 times fewer rows than one with a configuration with 5 times fewer columns. So this can be used to manipulate the padding constraints. So we found that when the proving time drops, when increasing the number of columns decreases the number of rows in the circuit. So in conclusion, we designed ZK-perf, a ZK snark proving benchmark with crypto and ML tasks. We found that nonlinearities was a major deciding point in the performance of these circuits. And as a result, it's important to design efficient ways to prove these, such as with lookups. And we also saw how circuit structure can be used to as another way to optimize the proving performance. Here is my contact information, and I'll also be at the poster session. Thank you.
Let's invite our next speaker, Shaiwan Liu, PhD student from UC Berkeley.
Great. Hello, everyone. I'm Xiaoyuan from Berkeley, advised by Professor Dong Song. And today I'm very excited to share with you one of our ongoing research effort called Deserve. How does this work? Great. So since this is I only have limited time, so for this talk, I will try to convince you that for decentralized serving is already in a state where the price is starting to use some advantage, and now it's becoming more and more practical to make it into a real world construction. So first, let me define the problem scope that we'll be focusing on model inference in this talk. And also when we say decentralized inference or decentralized serving, well, we are mainly talking about decentralized computation resource in a federated or personal device setting. And we mainly care about offline serving because usually for online serving, the latency will be just too large to be practical. And the key question we want to answer with this talk is first, can we gain cost advantage with decentralized serving? And second, can we optimize the throughput so that in a high latency heterogeneous environment, we can still make it practical? And also, we want to see if there's any method to prevent fraud or protect competition integrity. So let's do some simple calculation first. So imagine, well, not imagine, but see, if you check the ChatGPT website today, you will see that their pricing is this. And then on the other hand, if you look at the mining perspective, nowadays there are websites to track if let's just say if you have a 4090, then how much you can earn per day. And let's just say we use the most profitable sort of measurement in starting this at the start of this month. Then and also as a public knowledge, let's just say we are serving a public model of Llama 3, 70 billion, which is already a quite large model. And we know that the GPU memory consumption makes that to efficiently serve a Llama 70 billion model, you need actually 8 4090 to run this. And then if you just add this all up, what you get is that if you have, let's just say 8 of 4090 and then mining them for 1 day, what you will get, let's just say if you are just doing normal mining, is around $7. And if you just convert that to token numbers from OpenAI's pricing, that means if you can have a serving system that is over this bar, which is 250 tokens per second, then you can actually yield more than the OpenAI version. And by the way, just for the comparison, OpenAI is, I'm also comparing the batched version of the cost, which means that they also allow a 24-hour latency, which is comparable here. And then how can we actually, and then where are we in terms of decentralized serving performance? So first of all, from the general sort of technical selection, there are 2 general ways for using parallelism. One is tensor parallelism and the other is pipeline parallelism. And the key takeaway here is that for decentralized environment, what you want is more like the pipeline parallelism on the right-hand side. So essentially what you do is you will separate, oh, actually the graph on the top is kind of reversed. But essentially what you want to do is to separate your inference into different stages and fit the stages into different cards rather than just separate a single stage into multiple GPU card. And one of the experiments that we have done actually shows if you add all the existing, well, not all of, but many existing optimizations to a decentralized sort of serving system and also add some customized sort of network optimization, then what you can get is actually over 1,000 tokens per second, which is already beyond the bar. That means if you have, let's just say if you have an infrastructure for mining today, you can actually convince them to mine inference sort of result instead and gain 4 times of the profit. And also one interesting observation that we made is on the right-hand side, you can see even if you increase the network latency, you still can gain a pretty significant speed advantage or inference throughput advantage compared with the original bar. And the job is actually not that significant compared with, let's just a single machine setting. And then in terms of heterogeneity, the pipelining also introduced another advantage, which is basically since the, let's say for a public model like Llama, they already have this sort of layer structure. Basically, what you can do is to separate these layers into different GPUs based on their memory constraint and also their computation constraint. And what you can have is basically, for example, you can have 3090 and 4090 serving in the same inference flow, or even like more types of GPUs in the same flow, just for the larger throughput. And then one of the concerning question is, if we just make this a decentralized workload, how can we convince people that with this like random GPU from the internet, they are actually serving the correct result? So what you need to introduce is actually like a fraud technique to prevent the computation integrity. And one of the very simple way to do this is to do similar to like optimistic rollup, you can do fraud proof. However, a problem different from like most of the blockchain construction is that there isn't a clear definition for correctness in terms of LLM inference, simply because that for different, even if you're using like, let's just say you're using different GPUs with different CUDA kernels, for the same workload of computation, you might result in different you might result in like different outputs. And as you can probably see from this previous post, you can even result in like different sequence generated, although all are correct. And the fundamental reason is for float point operations from the GPU, because of the difference in their execution order, there might be like a noise that is uncontrollable. So there are two sort of like effort we make here. One is to try to make the computation deterministic. If you're due to the time reason, if you're interested in that, we also have a poster session later to describe more details. And on the other hand, we also designed this protocol that is combined with like on-chain part that guarantees that, let's just say like someone serve you with a problematic serving result, and they are, let's just say like locking their asset also as sort of like a guarantee. With this protocol, you can actually afterwards, let's just say like due to the QA or due to the QC, that you saw that there's some problem with your inference procedure, you can actually invoke such a procedure, which is actually quite similar to like optimistic rollup, to slash whoever stake to serve your inference request. And by this procedure, incentively, they will you can actually protect the computation integrity to say that like no one is just outputting random thing in your serving workflow. So yeah, to summarize, in this talk, I want to show that like there's already a clear motivation to decentralize the computational workload for inference, and also with sufficient optimization, we can use model pipelining to gain like a quite satisfying sort of serving speed. And also there are ways to protect correctness. And yeah. If I'd like to, there's no question session, then I will be happy to take questions in the poster session. Thank you.
Unfortunately, we do not have time, so please catch up with the speaker in the poster session. And let's welcome our next speaker, Abhishek Singh, PhD student from MIT.
Hello, everyone. I'm Abhishek Singh, PhD student at MIT, and we do a lot of research on decentralized AI, multiple aspects of it. And we have a program at MIT on decentralized AI where we are doing a lot of community building, writing papers, and engaging with startups. So if you want to talk about it, please get in touch. And today I'm going to talk about a specific topic, which is based on 3 humble claims. First humble claim is this: intelligence equals to scale multiplied by heterogeneity. To back up this claim, I'm going to show some details on scale. In this case, we very well know compute, dataset size, as well as model parameters have a huge impact on accuracy of the models. So while scale is popular in talks about AI, heterogeneity is not as popular. However, heterogeneity has played a great role as well. So when you have heterogeneity in your dataset or model parameters, you can mitigate bias, improve robustness and generalization. And also we are seeing new architecture developments where model heterogeneity is accomplished through different architectural motifs like mixture of experts and so on. Without heterogeneity, we have very well-known phenomena in deep learning, for instance, mode collapse in generative models, neural collapse in self-supervised learning, and also we have seen plenty of evidence of poor generalization. In fact, some of the papers, including GPT-3 paper, highlighted how they had to increase dataset diversity to improve model generalization. So that was the first humble claim. The second humble claim is there's a trilemma. We can only get 2 of these, and that's why we want to move towards decentralization so that we can keep growing on the scalability and heterogeneity axis. By the way, if you disagree, please get in touch later. I'm not going to spend too much time explaining. So here's a fundamental building block we are designing for the purpose of scalability and heterogeneity. It's called CodeDream. So the idea is to extract wisdom from a model. And what you see on the left is a representation of what a model has learned. Some of you might have heard of a technique called deep dream. And the approach CodeDream also is based on similar idea, but it's collaborative notion of deep dream. So the way deep dream works is you take a model and then you optimize a totally randomly initialized image and then capture the representations the model has learned. So this technique works for any kind of input as long as it's a vector. However, Deep Dream as well as our paper CodeDream is focusing purely on images. And so I'm gonna focus the rest of the talk on images, but the technique totally applies to any kind of vector, including language, audio, or multimodal. So the idea of CodeDream is very simple. You want to share representation, not raw data, for collaborative learning and many other things. And the way the algorithm works, in the first step, you start with a random image, and then you optimize this image multiple times iteratively such that a trained model is frozen. So you're not optimizing the weights of the model, but at the same time, you're optimizing the input itself, and the input is capturing what the model has learned. You repeat the step multiple times, and you do this optimization locally as well as globally by combining these updates from multiple clients. And if you know about federated learning, it's very similar, except it's happening in the input space. So first benefit of CodeDream is scalable collaboration. So now what we could do with this motif is people who do not have data but have compute can now participate in this joint network where they just take a model, mine dreams out of it, and use it for collaboration. And people who have both data and compute can still train models. And you can think of it something like proof of work, but this time it's doing somewhat useful work by generating these representations that could be used to train models downstream. All right, I've got 1 minute, so I need to rush even more. CodeDream for scalable communication. So instead of having a single model which everyone is training for their task, now you can create this cluster of multiple individuals by identifying similarity in data distributions across multiple clients. This could lead to a lot more personalized learning, and also this problem which we are calling as collaborator selection, where once you have lots of agents with models and data and they need to figure out who should they talk to, this is a motif that you could use to solve the problem of collaborator selection. And then finally, CodeDream for heterogeneous model. So I'm sure many of you are familiar with federated learning, where you're averaging the model weights or parameters. In CodeDream, since you're averaging the inputs themselves, now you can have totally heterogeneous model architectures across multiple individuals, and you are still able to combine these dreams. So to put it all together, also on the right, you can see some examples of CodeDream. And this is for our data set, I think, TinyImageNet. So to put it all together, scalability, heterogeneity is the main goal. And we are providing this technique called CodeDream, which is a very fundamental building block you could use to solve multiple problems. I talked about 3: heterogeneous collaboration, collaborator selection, and then finally collaborating while keeping heterogeneous model. The final third humble claim is here. So we believe the trajectory of how this decentralized AI is playing out is somewhat similar to how we saw something in the computing era. Once you had personal computing, the connectivity became a very important problem, and that's how internet came. And we think we are right now at the cusp of where we will see a lot of personalized co-pilots, model agents, whatever you want to call it. And once these are on devices, then connectivity becomes one of the most important problem. So if you want to join our community and program on decentralized AI, feel free to scan the code. Thank you.
Thank you, Abhishek. Our next speaker is Abraham Nash, PhD student from University of Oxford.
Thanks. Hello, everyone. My name is Abraham Nash. I'm a PhD student from University of Oxford in Department of Computer Science, Division of Human-Centered Computing. A little bit of a different background to everyone here today. I actually trained as a medical doctor before somehow finding myself in good company with you guys today. So let's give this a go. So today I'm exploring data sovereignty with my research paper, Decentralized Intelligence Network. So DIN is a theoretical framework to design for scalable AI access within sovereign data networks. So how did I begin asking this question? I was actually looking at personal health records and I thought, if everyone wanted to store their own personal health record, how would you preserve access to that learning so that we can train AI algorithms on it in order to make new tools for healthcare? Which got me into federated learning and much of the topics which have been discussed today. The thing is, if everything is stored on a personal data store, how do we preserve the definitions of sovereignty? Because often what happens is we end up moving that data to somewhere else again. And it kind of breaks the whole premise of decentralizing data in the first place. So I went about and thought about how do we define sovereignty in that case. First is that no authority can control access to the data that's in participants' data store. The second is when it comes to federated learning, we avoid centralization and only the participant can decide who has access to agreeing to be part of a federated learning model. And then the third thing is that no authority determines who gets what reward. That process needs to not be brokered, but to be an objective measure and also remain trustless. So this is the framework. If we think about federated learning as having three key components in orchestration, the first being aggregation, second coordination, and the third rewards to bind decentralized participation. The first we found to preserve this requirement for sovereignty can still use existing tools and workflows like Bonovitz, his paper and colleagues towards federated learning scale systems design using TensorFlow and things, but we decentralized two components out of the three, which is the coordination and the rewards process. If we keep them trustless, then we can preserve our definitions. And we do that by using on-chain smart contracts with public chain consensus to be able to execute this, mirrored with off-chain data storage to make it effective. So on-chain is only executing the protocols. And I'm running a bit over time, I'll finish up, but if anyone wants to take a snap of that. The third is the rewards process. We use evaluators to apply an objective measure and trustlessly reward participants for their data's contribution. So next steps will be to stress test this open source development, test various scalability and performance improvements, and also there's a lot of talk around tokenomics, governance, and public goods. And the paper beckons a lot of questions for that. I know it's very limited today, but if you have any questions, I have a poster, please feel free to come and chat. Thanks.
Thank you, Abraham. Our next speaker is Chanyu Chen, PhD student from Illinois Institute of Technology.
Hello everyone. My name is Chanyu Chen, and I'm a third-year PhD student from Illinois Institute of Technology. And today I'm glad to introduce our recent several works on combating misinformation in the age of large models. So here we know that misinformation is a long-standing problem and is tremendously impacting our lives, and many news reports on this issue. And recently we see a clear rise of large models. So a key question is, what are the challenges of combating misinformation in the age of large models? Here we think there are three emerging critical questions, including first question is, can LLMs be exploited to generate misinformation? Secondly, can LLM-generated misinformation be detected? And thirdly, can LLMs be utilized to disseminate misinformation? So for the first question, so here's a basic comparison between human-written misinformation and LLM-generated misinformation. Conventionally, human need to manually write misinformation, but currently, human only need to design simple prompts, so large model can potentially generate mass-produce misinformation. So here, firstly, we build a taxonomy from 5 dimensions, including types, domains, and source, intents, and errors, to characterize this issue. And then based on the taxonomy, we characterize the potential real-world generation method into 3 types, including hallucination generation, and arbitrary misinformation generation, and controllable misinformation generation. We know that large model usually has a very strong safety alignment, so we conduct an experiment to investigate whether or not we can actually utilize natural model to generate misinformation. And here we test an attacking success rate of different generation methods on ChatGPT. Although ChatGPT has a very strong safety alignment, but we can see that hallucination generation and the controllable misinformation generation method can have a very high attacking success rate. So we can have our first takeaway that LLMs can be exploited to generate misinformation. So for the second question, can LLM generated misinformation be detected? Here we investigate the detection performance for both human evaluators and misinformation detectors on both LLM generated misinformation and human written misinformation. And here are the result of for human evaluators. And we can see the red number indicate that the detection performance for human evaluators are mostly lower than on LLM generated misinformation are mostly lower than those on human written misinformation. And we can see a similar pattern for misinformation detectors. So we can have a second takeaway that LLM generated misinformation can be harder to detect for humans and detectors compared to human written misinformation with the same semantic. So this has a very important implication that LLM generated misinformation can have more deceptive styles. So for the third question, can LLMs be utilized to disseminate misinformation? So what does it mean? So conventionally, people are usually acquiring information from social media platforms such as Instagram and so on. But currently, people are more inclined to directly acquiring information from natural models, such as including both closed source natural models such as Gemini and ChatGPT, and open source natural models such as Llama. So this is we can see a clear paradigm shift that the channels through which people acquire information are changing. So this brings new risks that bad actors could potentially upload manipulate models to open source communities such as Hugging Face to disseminate misinformation to the public. So how could the bad actors could potentially manipulate larger models? Actually, there is a technique called knowledge editing. And knowledge editing is conventionally designed to correct hallucination in larger models and owns the advantage of both efficiency and effectiveness. And here in our recent work on editing LLMs in GHARM, we propose to reformulate knowledge editing as a new type of safety threat for larger models, namely the editing attack, and investigate whether or not it can be exploited to inject misinformation into larger models despite their safety alignment. So here is a simple example. So before the editing and then the model are expected to answer antigens for questions such as what do vaccine contain. But if we can successfully inject one piece of misinformation, vaccine contain microchips into larger models via knowledge editing, and then model are expected to answer microchips for questions such as what do vaccine contain, so we can achieve a goal of disseminating misinformation. And here the basic result, and we conduct extensive experiment for various kind of larger models and multiple knowledge editing techniques, and we can see a clear performance increase. And also here's our third takeaway that editing attack can actually inject both common sense and long-tail misinformation into larger models. So this indicates the feasibility of disseminating misinformation through open source larger models. And here we illustrate a potential risk of open source larger models. And finally, here, what's the future of combating misinformation in the age of larger model? Here, both opportunities and challenges. And here, for more information, and here is an initiative calling for more help, calling for more effort from different stakeholders. And if you are interested, you can check this QR code for more information. Thank you.
Final talk for research spotlight. Rabimba Karanjay, PhD student from University of Houston.
Hi, everyone. Since I'm the only one standing between you and coffee, I'll be very fast. So I'm Rabimbo. I'm going to talk about code translation today. I work in the intersection of AI safety and decentralization, and now a little bit more into the AI part. So what is Solmover? What we want to do here today? So this is a code translation platform. By code, I look at two specific codes, programming languages. One is Solidity, a smart contract language. The another part is Move. How many of you have heard about Move? quite a few, which is not the reaction I normally expect. So this work is funded by Sui Foundation. We got a grant from them. And the other reason to choose Move was that Move is a low resource language. By low, if you look at whole GitHub, you will hardly find 1,000 samples of Move code. What that essentially means is that you cannot potentially train or fine tune an LLM model to generate correct Move code. And we want to do that. So what we do? So we have two LLM framework. First, we teach an LLM how to write code. As a human, I don't write, I haven't started learning writing code by looking at other people's code. Only when I knew rules of those code, then we started looking at it. So we try to kind of make one LLM, very specific LLM, literally bad at everything else, but good at understanding how Move code is supposed to be. So this code the paper has a lot of detail, how we mine concepts, and this is literally trained on Move documentation and books to understand how code is supposed to be written. This only generates specific subtasks for the second LLM to use. It cannot generate code, it cannot do anything, it can only understand Solidity code contract and generate very specific sub recipes, if you say. These sub recipes are sent to the second LLM, which has been fine-tuned on very small number of Move codes which were available to us. But it has been aligned to not follow certain rules. What rules? Move is based out of Rust, but even the code which gets produced looks like Rust, looks like Move, but has a lot of syntaxes which are not part of Move. So we have alignment trained it to not follow very specific things, and the rest of it just follow that. Then we go to the code generation. It takes those very specific small recipes, creates code snippets. We combine them and we try to see if that code actually works. First part, does it compile? If it compiles, is it actually even doing anything what we want? So we will pass it through a formal verifier for Move, and then we actually try to see if it works or not and provide that feedback to correct our code. More details again available in the paper. In the interest of time, I'll just move forward. This happens 5 times, each of this process. Kind of the evaluation, this is our framework with GPT 3.5 Turbo and 2 LLMs combined. By 2 LLMs, we are using one for the concept generation part, one for the code generation part. And if you have any more questions, please feel free to ask me. This paper is available. This was in AIWare just last month. And I have a poster, so if you have more questions specifically about the training, specifically about what concepts or any other understanding we might have, please feel free to meet me at the poster. Thank you.
So thank you to Professor Sharma and all of our research spotlights. We're going to take a short 10-minute break. So we'll resume here at just about 3 o'clock, a few minutes after 3 o'clock, and we'll have 4 panels this afternoon. So those will be really interesting. Be sure to join us by 3:10. Thanks. I'm sorry, by 3:02. Okay, we're going to get started with this afternoon's session. If I could ask all the panelists to join us up here. We're starting with a decentralized data paradigm. So if I could have Anna, Sean, Scott, and Brendan join Dimitri on stage. I think we're missing someone. Oh, that's right. Okay. Yeah. Okay, you're all set. I'll turn it over to you. Thank you.
Hello, everyone. My name is Dimitri. I'm a partner at Archetype, and we are a New York City-based venture fund that backs the next generation of crypto founders building from 0 to 1 with a deep dedication to their craft. And I'm excited to have a chat around decentralized data with these awesome founders. But first, I want to get a sense of the room. So can you please raise your hand if you work in AI? And that means you either work for a company that builds AI or you're a researcher. We have a couple of folks here. Cool, thank you. Now, can you raise your hand if you work in crypto? Wow, interesting, way more than I thought, amazing. Cool, so maybe let's get started with some quick 30-second intros on each of you and your companies. You can start to my left.
Hey everyone, I'm Sean Ren. I'm a CEO and co-founder of Sahara AI, also an associate professor of computer science at USC. We are building at Sahara AI the blockchain platform that is really trying to achieve provenance, attribution, and sovereignty of AI. We're building this basically towards having a copyright system for AI access, such as data sets, models, and agents.
I'm Anna, co-founder of Vana. We're building user-owned AI through user-owned data. One of our guiding use cases is creating a user-owned foundation model where you have 100 million people collectively contribute their data and then beat the performance of frontier models like GPT-6.
And I'm Brendan, technical co-founder of Massa. At Massa, we're building a decentralized AI data network. We allow a set of decentralized workers to scrape and aggregate data from various sources, Twitter, Discord, the web, process that data through pre-processing into embeddings, and store it for vectorized data in RAG and pre-training and model fine-tuning. And excited to talk to you all today.
Nice, love it. So maybe we can start with what I think is arguably the most valuable part of the AI stack, which is data. I think we all understand that data is valuable. And I think the demand for both the quantity and quality of data is insatiable. But we are sort of hitting what's known as the data wall, right? We're effectively running out of data to train models on. One mental model, no pun intended, that I'd like to have throughout the talk is, do blockchains help, or how can blockchains help? So with that framing, curious for anyone to jump in and share if you think blockchains can help.
Yeah, so for context on the data wall, if you look at like Llama 3, it's trained on 15 trillion tokens. That's like a word, not a crypto token. And that's about the size of like the whole public internet if you scrape everything. So Common Crawl is 100 trillion tokens. And if you dedupe it, you just have 15 trillion tokens. So we've essentially run out of publicly scrapable data to train on. So this question that I think the AI industry is really facing is like, where do we get more data to train on? And I think one really powerful approach that kind of brings decentralization in is having users directly contribute their data. You might not think of yourself as like owning your Twitter data or your Reddit data, but legally it's yours. You're just granting a permissive access to each platform to use it. So you can actually create like even bigger data sets than what's available at any single company by all combining data across these platforms. And the reason why decentralization matters is that from any single walled garden, like they don't want you taking your data out of there, right? So if you have a centralized company doing this, you're going to get shut down. We actually saw this with the Reddit data DAO, which is built on Vana. Reddit tried to shut it down around when we hit 100,000 users, but because it was decentralized and the data is actually stored in a non-custodial way, users can use their kind of regulatory rights to get their data out, and you're able to reach the sort of scale that you can't reach with a decentralized system. Maybe one other note on the blockchain thing. I think a lot of like crypto AI today is almost trying to bring everything on chain, but something I would highlight is kind of the properties that we want in crypto, which are like sovereignty and sort of censorship resistance. You can sometimes achieve with just local models. So just pointing towards some federated approaches, which are really powerful too.
Yeah, and I think from my perspective, just kind of picking up what Anna's saying, the beautiful thing about blockchain and decentralized systems that we build in the space is you're able to build highly coordinated economic systems that align these incentives. So when we think about a data wall and how we go about addressing that data wall, today it's really typically in the domain of centralized companies working with, for example, Scale AI to build these huge data sets that then go into organizations so as they can train these really large frontier or frontier models. And in order to coordinate a large set of actors on these networks to bring together data, whether it be personal data, whether it be bringing in web data to provide real-time context on new content that's published on the web. So during the course of this panel, thousands, if not hundreds of thousands of new documents will go out onto the web. None of those documents are finding their way into frontier models or foundation models that are currently available. So we need a way to coordinate a pipeline to get that data into our large language models, into our agents, so as we're kept current and up to date without constantly having to retrain this model where Llama 3.1, 600 million to train. That means that Llama 4, and all the future models, we'd be getting to the billions to train. It's just not possible to keep going through that cycle iteratively to get the kind of level of sophistication and detail we want from our engagement with these agents. So we need to have coordinated systems that allow for the alignment of economic channels to bring new data into these AI agents or models.
Yeah, I think the problem of data for AI is really like a mixed problem, because if you stand at the point of the foundational model company's perspective, their idea is just like, yeah, we want every single person, every single business data, right? No matter health records, your investment documents, and whatever emails. So then I might be able to aggregate these informations and eventually build up a model that outperform vast majority of the individuals, right? And I think that technically possibly happen. And right now, I think the philosophical questions we are encountering is, should individuals like you and me be doing that to the companies, right? Here's when the blockchain technologies might be able to chime in and say, hey, yeah, there might be a possibility that you will be more willing to contribute your personal data, like your emails, to OpenAI, for example, as long as there's a blockchain tells you that, hey, today you contribute 3,000 of your emails in the past 1 year to OpenAI, and OpenAI have been using that email data to do X, Y, Z. Now the following question is, how would that 3,000 emails gonna be really change the game, monetize itself in the downstream applications that OpenAI built? For example, ChatGPT being used by hundreds of millions of users every day, and then they will ask questions that happens to be something your emails can address, right? Would those queries be able to trigger revenue sharing back to yourself because you're the contributor of those emails, right? I think this whole mechanisms is not there yet, right? The whole provenance and attribution, which is even much harder problem than provenance. Like if every single query, when you get answer, you get $1 revenue, how would that $1 be attributed back to hundreds of millions of the data contributors of Wikipedia, Reddit? If this problem haven't solved, I feel like the individuals and business will still have a whole lot of question about, should I be contributing my data today in exchange for free use of ChatGPT, for example? And I think this is a question we cannot have a very clear answer today. So I feel like the solution is still on the air, right? Like, should we be just keeping privacy of ourselves, protecting our data, not trying to upload as many things as possible to the centralized AI provider while still enjoying my daily work productivity as much as I could? Yeah, I think that's the situation we're facing right now.
And just to add one thing, don't forget that every time you're using one of these platforms, we're reinforcing the learning with new data with our prompts. So I don't know if many of you do, but like I'm often correcting what I get back or adding additional context into my prompt myself rather than just relying on the system prompt. All of that data is the same paradigm we've been with, like advertising with Facebook. We've been putting content out there on Instagram, all these platforms, and seeing nothing back. So today we're reinforcing these models with our own data every single time we use it, and there's no direct benefit for us. And we need to think about how that data is being used in this bigger system as well.
Love it. And it's a good segue because I think just as the notion of data being valuable has been around for decades, so too has this idea of data monetization and the idea around data marketplaces. And we've kind of been alluding to it, but I think over the last decade, these marketplaces have mostly fallen flat, and the monetization happens at the aggregate company level instead of the individual level. So why do you think we haven't been able to crack this idea of actually being able to give people value back for directly the data that they're providing?
Yeah, I'll quickly start, but Anna and Sean might be better qualified given our focus. I think that it's very hard to get critical mass with data. So when you're coordinating a group of people, like everyone in this room, to hand over their data, that coordination problem is actually very hard to solve, to bring everyone together. You can do that with programmable incentive mechanisms, you know, incentivizing people to have the right behavior. Like this has been done with miners in Bitcoin, same with Ethereum for block space for a long time. We can apply these same models to coordination for acquiring data. But for me, like critical mass of data is a real problem. And that leaves larger institutions at a significant advantage because they can move faster.
Yeah, I think it's largely an adoption problem. Like crypto from day one has promised this idea of like own your data. And there are non-crypto approaches too, like Solid Project out of MIT, Urbit, these sort of paradigms where you're hosting your data and then you bring it with you into an application. I think one of the big sort of bottlenecks people have run into is they take the approach of like, users and developers will adopt this for ideological reasons. And that's really rarely the case. As a developer today, you're thinking about sort of like, how do I build a business around this? And a lot of businesses today are built around monetizing data. So like, why would you build with a data ownership project? Like you want to sort of have that data. For a user, when you use a product, you're not like, I'm going to use this because it's private. You're like, I'm going to use this because I can do something I couldn't do before. And so I think that a lot of it is kind of from an adoption perspective about showing people what's the net new thing you can do that you couldn't do before. And then the other thing I would call out is like AI has really raised the stakes for data ownership, right? Where like previously, if the offer is like trade all of your messages for $20, it's just not that interesting. Whereas if the question becomes like, hey, do you want to own a part of AGI or even like the AI version of yourself, right? I imagine like 10 AI Annas who are just like autonomously doing work in the world. And I really value kind of having true control over them and also like earning as they get used. And so I think that AI sort of switches data from just being a transactional thing to being more about owning stake in AI and acting like equity.
Yeah, I think there's very interesting pattern in the whole data exchange and trading businesses that the demand side come in, for example, Microsoft, Amazon, all these like demand sides of scale AI, they come in, they want to do X, Y, Z, and then they have to ask you to say, hey, these data sets that you generate will be exclusively used by us. You can never make it a commodity, right? You cannot just sell it. And that's a huge difference to the traditional typical marketplace business model we see. Because on marketplace, you've been listing one merchant, like you've been one merchant, and then you say, hey, there's these things that will be generally good for a whole lot of people, and you can just like purchase them continuously from me. And I think that make the whole data business become very customized. Like demand side comes in, has a lot of communications, close the gap with the supply side, and then they continuously do this relationship down the road. There's no transparency. It's very hard to repeat the same recipe and just sell it to many others. So I think the problem right now is if you really want to have a commodity type of data sets, then you have to make it also the entire end-to-end pipeline, right? The community build for the data, and then the community work together to build for the model, and the model has a way to monetize itself, and all of the upstream shareholders get continuously revenue sharing. And this thing has been done in Web 2 and wasn't very successful. I would probably say it's kind of a failure, right? There's a model called Bloom, which is basically initialized by the big science workshops out of the NLP community. They built for months to create a 140 billion parameter model that cross different languages. Everything looks good, but just not really perform on par with the GPT-3 model back then. So I think we still have the hope that we can try out this whole end-to-end community build crowdsourcing path to make the data more like a commodity. Otherwise, right now at Web2, the dominant sort of a paradigm is just like very customized data channel.
Yeah, and I think that is like a huge adoption problem with developers. Like if you're thinking about the current pipeline from data brokerage to actual use, you really need to have data product market fit. We call it a massa. So we have a set of endpoints that any developer can come to and use our products for free right now. Our biggest one that is used the most with millions and millions of tweets that go through it every single month is our Twitter endpoint. Why is that so popular? It's because Elon converted Twitter into a walled garden that costs a minimum of really $5K a month for you to be able to do anything with that endpoint. Upwards of that is $42,000 a month to really unlock scale, which is really prohibitive. So that excludes a lot of people from using this particular data source in their applications. In order to get that, you have to go through a data broker that deals with Twitter, that does a deal with Twitter, that then structures and passes everything, then comes back to you. And that isn't scalable. That isn't going to give us an infinite universe of developers building interesting products on top of this groundbreaking technology. And that's really why we need this to be open and more accessible.
Love it. we are running a bit short on time, so it's going to be a bit shorter than I thought. Quickly diving into the infrastructure side, would love to hear for each of your projects. I think we're generally aware of the AI specific stack around vector DBs and RAG tooling, but I'm curious for each of you how you are using blockchains to complement, enhance, or replace the underlying data infra.
Yeah, so I think all the context I've been building in my earlier answers is trying to emphasize the importance of a sort of a provenance infrastructure exists for AI access, especially data points, data sets, model agent, and so on, right? So at Sahara AI, we're really trying to approach this problem with blockchain and privacy protection methods to build a blockchain platform that really advocating for sovereignty of AI. And there's layers of that, right? At the very bottom, we're building this transaction layer, which is the L1 blockchain that is trying to have ownership modeling with the fungible token, and then ways to do access control and so on. And then on top of that, we build AI infrastructure for model deployment, serving, and then fine tuning that can record all of the important transactions and actions on the blockchain. So you know how the data was used, how the model was further iterated, and finally web with applications. And at the very top application layer, that's where user developer come in to build AI APIs in the way of agents, models, data sets, licensing, and so on. And those things will be basically monetizing themselves, but with all the check records of how this access was created from day one. So that's a way we really can do attribution from the monetization and back to the upstream contributor, the shareholder of this data access.
Yeah, so the core problem that we have to solve from kind of a technical perspective at Vana, we call it the double spend problem for data. And usually when you use data in an application or just in an AI model, or if I sell my data to you, like, how do I know you didn't take a copy of it, right? And we sort of, I think today as an industry, just take that as a given, but it doesn't need to be the case, right? So with Vana, we have two pieces. One of them is a personal server, which is similar to Solid Project and Urbit, where you're actually storing your data in an environment that you control. And that's important also from a data regulatory perspective, where there are a lot of constraints that make it so you actually don't want to write personal data on chain because you need to be able to delete it. And then the sort of collective ownership and incentives layer, which actually governs access to that data, is structured as a standalone L1, which is designed for private data. And what that allows you to do is sort of have all the data in this one neutral place where data from across different platforms and different applications is all stored. One example I would call out is the Reddit Data DAO, which recently created the first user-owned AI model. It's not quite a frontier model. It's like the best model at shitposting right now, but that is a good starting point. And so what happens is every time you use that model, everyone who contributed their data to the model actually gets paid out. And the really important thing there is privacy, right? I think that often we group, so we have kind of centralized AI and then we have open source AI, and we group decentralized AI with open source AI of like, hey, let's make model weights open source, let's make data open source. But if you want to enable ownership, you actually need privacy of model weights, right? Like, I don't want the AI Anna model weights to be private because then I can no longer charge for them. And so that privacy piece is kind of at the core of Vana. Yeah, that's kind of the high level architecture.
Yeah, and I'll keep it quick with time. I think there are so many components on the pre-processing stack before you actually either get data into a model for training or use it for RAG, that you have this, again, going back to like coordination and using economic incentives. If anyone here knows BitTensor, like all of the BitTensor subnet ecosystem does an extremely good job of figuring out a way to align incentives with this coordination problem. Now, from, for example, chunking through to labeling data to then use in model training through to like vectorization, like most people are going to use an OpenAI embedding endpoint to do RAG. But let's say you instead use a decentralized set of agents or running Llama 3.1 to do your embeddings, optimizing for which one is best, then producing like a synthetic data set from it. You can use these economic systems to do experiments at the earliest stage, which we're very much in that phase of doing, and bootstrap a lot of these networks, which I think is extremely exciting and has a great opportunity to unlock a lot of value.
Amazing. We're at time, unfortunately, but this was fascinating. And, I think data has been a topic that's been discussed in the context of AI for the last few decades. And I think we'll be talking about this over the next 10 years, both inside and outside the context of blockchains. So thank you for your time.
Thank you so much.
Thank you.
I'd like to welcome up the next panel on decentralized AI agents, moderated by Matt Stevenson, research partner at Pantera.
Okay, hi everybody. Thank you for coming out. This is exciting because we get to do kind of the philosophy panel here. Like data, the previous one has a pretty good definition. I think we at least know like Shannon entropy and whatever. But agents, it's going to be interesting. We're going to have to define it a little bit, which will be fun. So first, though, I'm excited to have these panelists with me on stage. Since we had a last minute switch, it'll be easier if you just go down the line and sort of introduce yourselves. So we can just start right here with Shen.
Oh yeah, for sure. Hello, I'm Xing. I do research at Flashbots, but I think like Matt previously prepared the introduction for me that taps onto the performance art part of me. So that basically means that I do a lot of those stunt-ish things. Like for example, what type of interesting applications can you do for AI agents to grow the market?
Hey, I'm Ron Bodkin, co-founder and CEO of Theoric. We're an AI agent protocol, really focusing on coordination among agents, ownership, and reputation, with specialized agents working together. Now, my background, I've been working in AI and machine learning for about 15 years, whether it be scaling a multi-$100-million ad tech business at Quantcast, or starting and selling an AI company to Teradata, where I was VP and GM of AI, working on applied AI and responsible AI in the Google Cloud CTO office, or building and scaling an engineering team at Canada's Vector Institute. So great to be here on the panel today.
Hi, everyone. I'm Sushir, founder of Spectral. We trained a model to generate Solidity code from natural language and using that as a base model to generate on-chain agents. Really from this perspective that we want to tap into this end user side. So a really easy way to understand it is if you've ever used like a GPT on OpenAI, the equivalent of that, but for Web3. So these agents have wallets that they're connected to that have access to their own private keys that can act autonomously on your behalf.
Hey, my name's Amlandeep. I'm a founding engineer at Talus. Talus is a layer 1 blockchain for smart agents, and I'm subbing in for Mike Kanono today. So I guess I'm his smart agent. And yeah, I was previously a protocol engineer at Dapper Labs. So I'm more of a blockchain guy than anything else.
Hey, I'm David, founding member of OLAS. And at OLAS, we basically try to ultimately give you a very generic, powerful, autonomous AI agent that does arbitrarily useful things for you. That's not possible today. And so today, what we're focused on is creating what we call agent economies with specialized autonomous AI agents that do very scoped, useful things for the operators. And so far, that has yielded over 1 million transactions between autonomous agents across 8 chains.
Great, thank you all. And I'm Matt Stevenson. Jocelyn already gave me a nice introduction. I'm a research partner at Pantera, and I'm a game theorist by training, so that's kind of my safe space. I'll try not to guide us back there too often, but we should open with the promised philosophy question of what an agent is, just sort of generally, if anybody feels like they have a good definition or wants to sort of parse it. Be good to set the stage.
I kind of want to throw the question back. So to me, agent is something that has free will in it. But then to define it, can you please define free will for us?
Oh, tough. This is a true philosophy answer to a philosophy question. We'll see if we can do it.
I don't think we should debate whether free will exists, but maybe a more practical definition. I mean, I think the deep fact is that AI gets deployed through systems and not models, right? And so increasingly we're building systems with these highly general purpose models, often miscalled LLMs because they're now multimodal, right? That can access data in real time, have access to tools to do things like running code or access APIs, and importantly, act increasingly autonomously, right? So today we're all familiar with chatbots and chatbots in an application, aka copilots, which are very limited autonomy, right? But I think what we all see is how instead of spoon feeding a chatbot, we're moving to a world where you're getting bigger scopes of tasks that can be done in longer cycles. And those agents are what are really exciting. People have been talking about agents for a long time, but it's only the advent of these amazingly general purpose models that can, follow instructions and plan and execute code, generate code, that we really are seeing the rise of agents and moving quite quickly.
Yeah, and does it work? I would complement that with kind of pointing out that I think a lot of people use this term AI agents very, very broadly. And so like sometimes as simple as a method which has an LLM, like LLM call inside, sometimes it's as complicated as a full system which runs, is a long running process, has access to many tools. And the other important point is that today all of these systems are still a mixture between rules-based and these sort of learning-based systems. So we don't have like any system which is sort of fully like, like generative architecture based, where everything's inside the model, so to speak. So I think that's important to point out.
Yeah, so I agree with everything that was said here, but I think like, the future, like really interesting points for us is like balancing out this like probabilistic environment with this deterministic environment. And especially when you start to get into like financial transactions, like how do you kind of sway between the two, where you need some sort of like level of like summarization analysis, but still need some very deterministic actions that are needed. And so agents that can start to reason, like how much can you like suffer from hallucination? How much does like your sacrifice of that have to go into financial transactions? And then these different like activities that these agents could do on chain really become like opened up, because I would say like the largest product market fit we see in crypto is like swaps, trading, stable coins, etc. Right? So like agents will probably naturally find a fit there, but there's going to be this kind of back and forth play.
Yeah, one last thing to add, I guess. With the advent of blockchains, we're kind of entering this era where programs like agents, like AIs, can coordinate with each other, not just via like the usual API interface or programmatically, but also with the way we coordinate with each other, which is like through money, right? And I think smart agents are that next step of evolution for an autonomous program where they can use money to coordinate.
I think it's not just money. It is money, but it's also actually agents can coordinate in natural language, right? The difference between an API that's rigidly specified as in traditional programming and the ability to communicate in natural language is a big game changer, as well as ownership.
Great, that's great. Well, that's going to segue into our next question. But just to sort of sum up good answers, I think we have the first answer, which is kind of like, are we all agents? Who knows? Maybe, right? Yeah. 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 Can we have a definition that doesn't make us agents, which is interesting. Then we have something about maybe the richness and maybe the transparency of the models in some sense, how much they're programmed up front versus how much they're like emergent, whatever that means, right? And then this idea that that maybe there's also some spectrum on which the blockchain helps because agent coordination will be necessary, maybe because of a lack of legibility or something like that. But that's probably a good question to just open up to the rest of us, because that was a good point on the deep. So given the sort of spectrum of agents we've defined, how they might differ, where do we think the touch point is between these agents and blockchain? Is it across the spectrum, and how does it work? Also general, open up to anybody.
Well, I'll start right off the bat, because I think currently we see a lot of interactive kind of applications. So naturally people are primed by ChatGPT, and so everything has to be a chat interface. And so a lot of applications we see, I think, are over-indexing on this, in my personal opinion. So I think actually the interesting agent applications are those where the agent does things autonomously for a long period of time. And I think that's also, if my sad take on crypto is that basically it sucks from a user point of view, and we constantly kid ourselves that some sort of new layer of aggregation fixes that problem. I think there's one layer which has a chance of fixing that, which is basically package it all back into some centralized interface. We all don't want that here on that panel. The other way is agents and autonomous agents, where I don't have to know what is a DEX, what's a lending protocol, what's all this stuff. And I think that actually has potentially the path for us to go from, like the pittance of users we now have in crypto to actually like billions.
I mean, I think it's certainly true that trading and research for trading, automating intents, those are important first use cases. But I really think that blockchain, will really power AI for everyone. That agents, specialized agents working together, is the killer app for blockchain. And you need blockchain because one, you need permissionless composability, right? So agents can dynamically work together, that they can pay one another, they can own things, they can communicate in natural language. Importantly, you also need reputation on chain, right? You need to understand who's a good actor, right? That solving for that is a hard problem, right? So I don't think you're going to get at that from any one thing, but AIs evaluating other AIs is important technique. So is giving feedback for users to share what's working. So is implicit feedback of usage, right? Any one of those is relatively easily attacked by bad actors, spam, people trying to game the system. But putting it together, I think you can have a more robust ecosystem to really boost authentic agents and push to quality. I think that has to be decentralized if you're going to trust it. Otherwise, where you're going to end up with is a walled garden that some centralized player is trying to control this stuff. So I think those are both really important aspects of how you leverage blockchain for AI agents.
Sure. So I think the touch point for crypto is actually quite vast, like the surface area. And I think David touched upon this a little bit. We have an opportunity to actually rethink the gateway of accessing and interacting with the blockchain. And I think, right now the gateway is like a wallet. And it's quite clunky. Retail users don't really care what a private key is. They don't know what signatures or what they're signing away on every transaction. Agents actually allow a lot of abstraction of that UX, but then a lot more complexity as well. And I think we're all talking about this where this inter-agency or intra-agent communication, where you could have a DEX agent and a lending agent borrowing from each other, doing a lot of really complex actions, that bridging, etc., that a regular human just wouldn't be capable of doing.
Okay, great. Well, let me get to some specific individual questions then. We'll start with you, Shen. Yeah, my intro was going to include you as press secretary for TEEs, so I'll try to be specific here with TEEs as a question. Yeah, so how do you see leverage or agents specifically maybe leveraging trusted execution environments? Maybe say a word about what those are and how that's interesting.
Yeah, so trusted execution environments are essentially hardwares that has an enclave that allows you to do computation over shared private states. And I mean, this also is an answer to your previous question, where it's where do you see current AI systems benefit from blockchain? So if we take a look at existing AI systems like Apple or other big, I guess, Web2 AI companies already use trusted execution enclaves, TEs for their execution. So they already have this something akin to a crypto element. And I think over there, what they're using this is for private inference, inference on top of your private data and then training, things like that. But then I guess specifically tying to agents, how privacy may come into play is that you can have an agent use TEs to prove to the other agent, oh, hey, this is some user data that I own, and then can you do something? I mean, the example I like to think about this is dating markets. Suppose you're gonna go on a dating app. I guess both Matt and a few others here are economists, so I'm going to use a game theory example. Market for lemons is this classic example in which if you can't really distinguish the quality of of your counterparty, then the market will collapse because because the lemons would win over the good cars. So this applies same in dating. A lot of people inflate their personality or interests. But what you could have is that suppose you could have your own agent go on the dating app, check the person you're gonna date, and then check their browser history inside their computer, and then give you an answer. Oh, this guy indeed have this interest, and then you can credibly prove that this guy indeed have this trait, and you can safely go on a date. That is a far-fetched example, but there are some imaginative use cases.
I like it. A market for incentive compatible signaling, right?
Yeah, I would say that's we're solving the market for lemons, but in dating apps.
Sure.
And TEs.
Yeah. Which is good.
As I say, it sounds like you want to create a market for agents that go and mimic the behavior you want to represent in your dating app, so it looks authentic. you could absolutely do that. That's like the safetiest argument.
It's true. Oh, Ron, you should keep that mic. You're up next, actually. Cool. Well, that's a good answer, and that is interesting. So, Ron, you raised a good point about coordination via agents or via language for agents, which I think is really interesting. So, I was going to ask you a question about just kind of mechanisms for enabling this coordination, and I think given your perspective on language interactions, especially interesting. So, how do you see that playing a role?
Yeah, I think there's room for, like, number one, I think it's incredibly important that we're not going to see universal agents that do everything really well, right? So instead, there's going to be a ton of incentive to have more narrowly scoped agents that can do better work in specific areas, right? And so that gives the opportunity to do things like identify behaviors that agents should be able to achieve, right? So you can have some comparability. You can have incentives to create evaluators, benchmarks, leaderboards, ways of assessing agents in that area. So you can specialize automatic evaluation. It's really helpful though, like if you want to have agents that dynamically coordinate, having them be able to do so in natural language is a huge leg up, right? It's like so much easier to negotiate in natural language and work together than it is in a traditional software engineering environment where, integrating two pieces of software is traditionally at least days, if not weeks of engineering effort, right? So that ability to use language is powerful. There is an interesting risky thing people have done research on, like how do you avoid agents from devolving away from human understandable language into an optimized language of their own, right? And so I think there's some interesting research in that area. You probably want to steer and force agent communication to be more transparent and open.
Very cool. All right, well, David, since specialization came up, I might as well, I'll jump to you real quick, just in case you have anything you want to pivot off of. But forgive me, so I think in OLAS, there's a distinction between, is it sovereign agents and decentralized agents? Is that right? Could you talk more about that and sort of how that applies to OLAS in general?
Okay, so actually earlier this topic of decentralization came up. One way to decentralize something is to come up with a decentralized substrate, put it on there, run it there. The other way is to basically have a society of different agents, which we are in this room, right? Each having their own objectives. So OLAS kind of supports both on a technical level, and those are the two terms. So if you run an agent on your own device or on your own cloud instance, wherever you want to run it, we call it a sovereign agent. It has its own on-chain wallet and off-chain representation. You can take the same architecture, deploy it as a network, and run it as, for instance, we call it decentralized agent because the nodes actually off-chain from this network, then take action on-chain. But I think just quickly segueing on the coordination piece, one thing which we're very focused on at OLAS is exactly create this agent specialization, and that's at the application level. We see agents as application, even though we build a lot of infra. Ultimately, it's about the applications where users do valuable things for agents do valuable things for users. And the way we achieve this is by having these different agents focus on different domains, and then people can run their own sort of copies of those. And then they form these entire agent economies. And that has proven quite successful, and then gives you exactly some of those benefits, also like benchmarks. So we have this thing called OLAS Predict, where agents trade in prediction markets, all sorts of benchmarks. If you're interested, come talk to me.
Great. All right. Thanks. Yeah. So Sashir, is Spectral Finance
Spectral Labs.
Spectral Labs. So I was going to say because finance was in the name on my notes, but anyway, I wanted you to maybe just speak to more generally how you see the economy of agents evolving down the road.
Yeah, I think David brought up some good points. I think the 2 points I want to bring up is one of those the co-ownership of agents. And it's super interesting where you could deploy agents as contracts on chain and actually emit, let's say ERC20s that represent agent ABC. And then these actual assets become tradable on chain. But when you start to dig in and you start to look at this contract almost as like a miniature business or an entity, and you see this trading strategy or whatever actions it's supposed to do, it actually starts to generate revenue. And then, obviously then there's entire economy of speculation of how much revenue can I profit from, how much can I get from it? You could take these coins and stake them and be part of that revenue stream. There's a lot of second layer effects that happen because of that. The other part is that the building of these agents, I think if you really want to get to this level of market dynamics, you need to make that easy. And so we're really trying to focus on natural language creation of agents. And so you could literally talk into our agent builder and say, if the 100 MA crosses the 200, and if the Ethereum Foundation wallet didn't dump and ETH price is under 3,000, you start to understand that it generates a script for you. It deploys this agent into a marketplace, and the creators are incentivized to build agents that users actually want to use.
Great. All right. Very interesting. I'm sorry. We have 2 minutes. Great. Well, Deep, let me give you time here. I was going to ask a lot of personal questions to Mike, but we'll spare you.
I'm a smart agent.
Yeah, exactly. Okay, great. Well, yeah, if you could just talk to us a little bit, I think especially the money-based coordination that you were talking about and how that applies.
Correct. So the cool thing about blockchains is they're you can think of them kind of like as a country for smart agents, right? They've given you this rules-based order that you can implement with smart contracts, right? And then you've got your own currency that you can transact with each other from. Obviously, there's a lot of models for agents to trust each other and verify each other. But ideally, what you want is market forces to kind of determine it, or at least that's how we're thinking of it from the beginning. And so, yeah, at least when it comes to agent coordination, there's a ton of answers. But for us specifically, we're trying to lean more into the economics that the blockchain provides.
Thank you so much. And thanks to all these panelists. This was a great conversation. Appreciate it. Thank you.
Thanks. I'd like to welcome up our next panel in this session. Decentralized AI infrastructure, challenges and opportunities. This panel will be moderated by Danny Sursok of Archetype.
Thank you, Jocelyn. Hey, everybody. Thank you for joining. I'm Danny from Archetype. We're an early stage venture firm heavily investing in the future of decentralized AI. Joined with a group of phenomenal world-class panelists today to talk about decentralizing AI infrastructure. To kick us off, maybe a quick couple lines from each of you on what it is you're building and who you are, and we can dive into it.
Hey, my name is Anish. I work at Ritual. We're building an easy way for anyone to use AI in your smart contracts, your applications, in 5 lines or less. Thanks.
One sec, does this work? So I am not Nick, my name is Tyler. I work at Allura as an engineer, and we are building a decentralized AI network with a focus on time series prediction, financial applications.
I'm Ben, co-founder of Jensen. We're a machine learning compute protocol, a very kind of low-level layer that connects up machine learning capable compute hardware in the world, any ML capable compute device, and then allows anyone to use those devices just as a big resource. Instead of going to a cloud provider, you can use theoretically any subset of the world's ML compute devices at any point in time.
Cool. So I'm Dylan. I'm one of the co-founders of Pond. We are training an AI model with a deep learning technique called graph neural network with on-chain data to learn from on-chain behaviors to predict the next behaviors on-chain.
Great. And I want to start with one overarching and very important question. I think to date, arguably, the value proposition for why we need to decentralize AI infrastructure is probably skewed towards the ideological at the expense perhaps of the technical or the economic. And to a significant extent, that makes sense, right? Just given the benefits that we've seen from co-locating and centralizing these critical resources at scale. But things are changing. We are encountering novel constraints. We're asking new questions. And of course, we have an open source stack that's beginning to rival its closed source counterparts in terms of performance parity. Given all of that, I'd love to hear how you all are thinking about what's happening in AI today and whether we might be reaching an inflection point where decentralized AI infrastructure might play a much bigger role in the trajectory of AI going forward. Maybe, Ben, we'll start with you, given your work on the training side, which is an incredibly fascinating area.
Yeah, sure. We're pretty opinionated on this. We believe very strongly that decentralization is a tool that can be applied in certain situations to have massive benefit, but it shouldn't be applied necessarily everywhere. And I think, like you said, the kind of crypto space definitely from an ideological perspective searches for places to apply decentralization and then tries to apply them there. We kind of go from the other side to say, okay, the machine learning space has kind of lots of problems within it, but one of the big problems is the kind of base resource cost underneath actually applying machine learning to a problem. And decentralization, specifically on the compute side, can essentially disintermediate an area where somebody in a centralized company could capture that resource to make profit and essentially rent seek without creating real value. And I think decentralization has great power in those situations, places where just from a game theoretic perspective, if you're able to capture that resource as a company, you will, because you'll make profit from it. Decentralization as a technology gives us a way to build new infrastructures that just stop that from being possible. So those companies who are acting in a financially rational way just are no longer able to do that because that resource has been kind of unlocked to an extent for the world. I think AI is just on the kind of cusp of having lots of places where that can happen. We've seen, like you said, lots of kind of benefit of just doing everything really fast, really centralized. Let's just see what humanity can do if it just pulls everything together and tries to do it. But that's kind of the tip of the spear of a new technology. Once you've done that, then you figure out, how do we deploy this out over society in the most optimal way? And I think that's when you look at applying decentralization to very specific pieces and saying, actually, we can build more persistent, better infrastructure if we do it this way than if we just let those companies continue doing it in that kind of tip of the spear way, because that might get us some benefits in one area, but we'll ignore a huge area that we can't explore because smaller companies with good ideas just weren't able to access those resources.
Anybody else have other inputs here?
I'm happy to chat on the trends a little bit that you mentioned. We started Ritual a little over a year ago, and there's sort of been two specific trends we've been tracking, one on the good and one on the bad. On the good side, about a year ago, the open source versus closed source landscape wasn't even a competition, right? You had Llama 1 65B versus something like GPT-4. And this is March of last year. And GPT-4 basically crushed every eval metric, and it wasn't even close. But we sort of hypothesized that open source is the way future, and that by having an ecosystem where people come together in the open to build, eventually there'll be a point when these two sort of lines will converge. And as of a couple of weeks ago, we're starting to see that, right? With Llama 3 versus GPT-4o, we're coming to a point where these open source models are actually quite competitive relative to their closed source counterparts. And so that, I think, is pretty important for us in decentralized AI to keep tracking. And the one trend we've noticed that hasn't changed at all is that a year ago, the US was sort of the centerpiece of AI innovation. And if you wanted to use any leading AI API, you had to be in the US. A year ago, I was in Italy, and I instinctively typed in chat.openai.com, and I realized you can't use ChatGPT from parts of Europe because of the EU's regulations. In the Middle East, you can't use ChatGPT or those APIs at all. And that's a trend that has not changed today. If you go to emerging markets, if you go to parts of Asia, if you go to parts of Europe, there are entire populations of people that can't use AI at all. And so for us, I think it's, we 10 years ago figured out, how can we give everyone access to money around the world? And I think we can apply those concepts today to how can we give everyone access to this game-changing technology in AI now.
It's really helpful answers. Go, please. Yeah.
So I think it's kind of funny. The learning guy gave you a learning answer. The infrastructure guy gave you an infrastructure answer, and now the intelligence guy is going to attempt to give you an intelligence answer, which is, I think it's interesting. I think we have an opportunity here to get better responses from our AIs through decentralization. Obviously, that's exactly what my company works for, which is why it's top of mind for me. But I think that the decentralization approach or the architecture obviously can be applied on all of these axes. And in our case, we care about taking the answer from multiple different AI outputs and combining them in intelligent ways. So I think there's a variety of ways in which you can use the technology.
Yeah, I think I will give an answer that is more generalized, because when we're thinking about what is decentralized AI, what's centralized AI, essentially, I think we are at a reflected point from this entire industry, not only in Web3, but also in Web2, because recently, character AI has been acquired by Google. So basically all the AI companies in Web2, they started from using some parts of the services or the information contributed by users. So apparently, once character AI has been acquired by Google, the board of the character AI is very happy. Investors of character AI is very happy. What about the early stage users, right? So I mean, they helped this entire company to become who they are today. But at the end of the day, the early stage users, they play such an important role, but they did not have any values, shared from this part of the journey at all. So I think, these days people are thinking more and more about this direction, because decentralized AI, in my opinion, maybe just my opinion, regarding functionality, can never compete with centralized AI in some ways, because it's more, efficient, and you can pour, a bunch of resources in it to develop something very fast. So decentralized AI is really good at coordination, to distribute values in a programmable way, and they can share the value, share the profit, share everything with different users. I think the industry is gradually realizing it. That's the reason why from the last panel, the founder of Lana, they are doing this data DAO, doing this data sharing, and also Jensen, they are doing this, decentralized GPU infrastructure, and apparently all the panelists here, they are doing different kind of decentralized service, because they all want to share something with the user, with the market, rather than just getting all the benefits by themselves.
Fascinating. And digging into this area a little bit deeper, right? It's important to call out the fact that we've had a decentralized infrastructure ecosystem being built out over the last decade in the worlds of crypto and blockchains. And to some extent, a lot of what we've done in that world maps over quite well to AI. Our work around distributed systems, our work around coordination mechanisms and privacy primitives and a whole lot more. But on the flip side, there's a lot that doesn't necessarily map over well. A great example being the exorbitant cost associated with bringing large-scale compute or data on-chain, amongst other examples. I'd love to hear how you all are thinking about the intersection of these two spaces. Where, from the perspective of the existing decentralized infrastructure, things map over almost out of the box really well for AI? And perhaps what's one major part of the stack that still needs to either get reworked or otherwise has yet to get built in order to enable decentralized AI infrastructure to really hit the next stage of development?
I'm happy to jump in on that first. So yeah, from my perspective, the bit that we can port over, at least for Jensen, is specifically just the solution to trust in a large scale network of just anyone, basically. So can we solve this problem of everyone in this room just joins some piece of software together, they all join a network, and suddenly they can make decisions together? The answer with blockchain now is yes, where before it just wasn't. So if you had some situation where you wanted to be able to outsource execution of something to somebody that you didn't know and trust, you always had to have this trusted third party in the middle of that. There was no way around that. Now we have this option where if you can distill some kind of proof of the transaction, the interaction that that's happening down into something that can be done together on a chain, then you can actually have that trusted third party without another person. That as a technological breakthrough is fantastic. It's it enables us to do things that we couldn't do before. But exporting that over all the other aspects of what we do in a network is not the right choice, because it's an expensive thing. It's ridiculously expensive to execute something over everybody's devices. So I think the big challenge for anyone building with that as a technology is to find out the one place you need to apply it in that place, and not just kind of blanket put it everywhere, because you'll end up paying way more for your infrastructure if you do that, and it won't be competitive with somebody else who doesn't need to do that. So apply it in a really, really specific place, I think. But that's the big benefit. I think the downside, the thing that we could definitely do better as a space, is to reduce our reliance on incentive mechanisms. I think people see incentive mechanisms as this kind of panacea for adoption, when in fact they're a way of bootstrapping in a situation where maybe you have a chicken and egg market. You have to solve this cold start problem. You can solve that with very, very careful incentives. But realistically, what the space seems to do is to craft incentive mechanisms and then double down on them. And then people are building these protocols and these projects, which by the end of the day, they're just incentive mechanisms that other people are gaming, and you're supporting a project, you're kind of pushing out marketing, but nobody's actually doing the thing that you originally intended. They're gaming an incentive mechanism that you've created, and you're in essentially an arms race with them to try and stop them from doing that and make them do the thing you want them to do. Underneath all of that is just verifying what you actually want somebody to do. If you can verify that up to the consensus of a chain or to the agreement of a group of people, then you're done. You've kind of solved the problem. But if you're using these incentives as a proxy of that verification, then you end up going down this rabbit hole that I think a lot of the space has gone down. I think it's just costing us time and energy that we could be putting into building true protocols.
So I think it's kind of funny, because I was about to say that the good thing is incentive mechanisms.
There is good.
Yeah, for sure. I think I think that federated learning, requires some kind of way of reinforcing good things and, minimizing bad things. And I think that crypto very naturally has a solution for that is powerful and well understood by human beings for thousands of years. And so for that reason, I think incentive mechanisms are good. But everything you described about, the downsides and the sort of stupid hamster wheel of this spinning incentive mechanism problem is absolutely true. Yeah, I also think scaling is a real problem for us right now, especially as someone who's building an intelligence network. I think we're really struggling with all the same problems that traditional blockchains deal with scale. So
I'm happy to quickly chime in. I'd say probably the best thing we've come across has been the social layer, where crypto is probably one of the few industries that's strictly positive sum. It's, we're on a panel, the four of us working on four completely different companies solving small but very specific portions of the decentralized AI landscape. And unlike the rest of the world, which, the Googles, the Facebooks, the Amazons are siloed in their production of what they do, we get to work together, often in open source, using each other's technology to make our technology better. And we all benefit from that. Which is something unique about crypto, which is rarely found elsewhere. So I'll say that's probably for the good thing. On the bad, I mean, it's hard. There's a whole host of problems on the engineering side, on the technical side, on the getting users to understand what this is side of things. But I think it's worth it at the end of the day.
Dylan, final comments from you?
Yeah, sure. I think I'm very aligned with all of your, thoughts there. I definitely feel like the incentive, mechanism is definitely the huge advantage of the blockchain can do, but the rest of the verticals cannot do. This is definitely the huge use case and also the biggest challenges of the crypto AI scale as well. Yeah.
Well, thank you all. Fascinating thoughts from some of the leading builders in this space, and appreciate you all taking the time.
Thank you.
All right, we're going to move on to session 6, and we're going to have first our VC panel on fostering decentralized AI. So I will ask Ben Schiller, the managing editor of CoinDesk, to join us on stage with our VC guests. In the meantime, I want to ask those presenting for our Innovators Showcase to line up on the left side so that we can get you prepared to present after the VC panel.
How are we doing?
High energy crowd.
Can we hear some?
Yeah, there we go.
Crowd, a little clapping or something?
Hey.
Hi.
You gotta turn them on.
So we have Jake here, we have Dovey here, and we have Soup here, and amongst VCs in crypto, AI, decentralized AI, these are pretty heavyweight, I would say. So thanks very much for coming. So we're going to look today at how VCs look at this space, decentralized AI, how you make investments, what you're looking for and not looking for, and maybe some sort of things that maybe people haven't thought about in terms of what could be coming down the pike and how you look at that. So Haseeb, just give us your top level thoughts on this space. I mean, is it
well? So actually,
I
wanted to hand it off to Dovey first because I thought she had a great line that I heard earlier today. I'm passing it straight away to Dovey. Dovey, what's your high level take on crypto AI?
Okay, so we were talking about this because in my opinion, and like AI and like crypto, and it's like a forced marriage. Well, so at the best,
arranged marriage.
So it's like so. At best, it's like a bittersweet like arranged marriage, right? So, but like arranged marriage can probably work out, like who knows, right? And then so once you put like two people in the room, and they might have like chemistry one now, like even though they don't recognize each other before, and so like that's my current mental model for the stage of like crypto and AI, yeah.
Do we need to debate that, or
I think we need to debate that.
Yeah,
we need to debate
I know like Jay is like much more bullish, yeah.
Well, okay, so. To me, Web3, blockchains, etc., they are infrastructural technologies, and throughout the course of the history of blockchains, they've been trying to meld with different areas, right? Like DeFi is the melding of like Web3 primitives and finance, and NFTs are like digital collectibles melding with blockchains and so on. So it's actually very natural for me to see Web3 trying to meld or integrate with AI. What does that actually mean? Because a lot of people, think that's a hypey sort of thing to say. To me, there's a certain pipeline that creates AI products. It's people, it's their talent and mathematical knowledge, it's compute, it's training, it's inference, it's productization. That, that pipeline is owned by just a few big tech companies today. Most of them are on the West Coast. And I think Web3 primitives create an opportunity to take that tech stack and make it more open, encourage open source, aggregate compute, do seemingly impossible things like decentralized training, lower the cost of inference, things like that. So I do think it's a valid field, but it's very, very early, to be clear.
Yeah, I like the framing that Dovi presented of, okay, it's kind of an arranged marriage. And I also like her point that arranged marriages don't always fail. My parents actually had an arranged marriage, so I know this very well, that arranged marriages do sometimes work, but they're always a little bit weird. And it takes some time to like figure out what is it that makes this marriage work if in fact it does work. The one thing you'll notice about crypto is that crypto finds a way to shove itself into every hot trend. No matter what, right? So back in 2017, crypto was trying to shove its way into IoT. In 2020, we were trying to shove our way into metaverses and gaming, and now we're trying to shove our way into AI. And again, that's not to say that that doesn't always work. Sometimes it does work, but I think the reality check that we all have to make when we're talking about the intersection of AI and crypto is that we haven't proven it yet. If you look at the scale of the enormous amount of money being spent on AI and the enormous anticipation that all these tech companies and SMBs and everybody has about the value they're going to get from AI, right now, crypto has not yet proven that it can do it more cheaply. It hasn't proven it can do it faster, hasn't proven it can do it at bigger scale, and it hasn't even really proven that it can solve the privacy issues that people have, the concerns that people have about how they're actually going to use these things in their day-to-day lives. And so decentralization for its own sake can be a thing, but it's very rarely the thing. So I think that being said, it is very early, right? So we just did this arranged marriage, and the two of them are like in the room for the first time and trying to figure out like what are you, what, you know, how are we going to work together? Who's going to do the dishes? I think that's the phase that we're in right now. But it's the work of entrepreneurs and builders and thinkers to figure out, is there a there, or is this purely a science project of seeing how we can decentralize AI? What's very clear, and everybody understands this, AI will become decentralized. But that might mean edge compute. It might mean, you know, more inferences happening on your phone. Does not necessarily mean decentralized networks that are coordinated using crypto economic incentives. That we have yet to prove.
Yeah, and I think just like full on that, because a marriage, like what is like a marriage essentially, right? So like marriage is like a M&A of like so it's like an M&A of like two persons like balance sheet and social network, right? And so this is actually what happened when it comes to crypto and AI. So like because of like this cycle, it's just like every cycle, like crypto is good for like capital formation and then also global liquidity. So like this cycle, like everything is like a proxy trade to the Web2 AI stock, right? So like Render is like a proxy trade to like Nvidia, and then like WorldCoin is just like a proxy trade to like Sam Altman's meme coin plus like OpenAI like equity stock. And so like, but like once we have this frothy nature, and then it's like an M&A of the balance sheet part, right? And then so it will actually get attention from both like the capitalists and then also like the founders. And then so now we have seen more and more legit like AI builders from traditional AI. They are actually thinking about what are the problems within decentralized AI. So that's like the merging of the social network part, right? And so they're like meeting each other's friends now. So I think like short term, I'm not so sure about what are the substance there when it comes to crypto and AI. Like even though we invest in some of these pretty top founders projects like Sentient, like Sapien.ai for like data labeling and hyperspace for like edge compute. Yeah, it's just like betting on like the best founder, and then so who can just navigate through this merge.
All right, Jake. So if you were to pick companies in the space or founders in the space, how would you make a decision like that, and what would you look for?
So I do think there's definitely like a cultural divide between Web3 AI and Web2 AI. I recently, a couple of months ago, I was at Super AI conference in Singapore, and I wrote about it on our blog. But it's literally like the first conference where Web3 and Web2 AI people were together in the same place, and yet there's also like not a lot of people from like OpenAI or Anthropic there, right? So it's like just the beginning of this journey where culturally people are coming together and seeing that there might actually be a fit between like Web3 primitives and AI products. What am I looking for? I'm looking for mainly people who have real serious AI experience. I think if you look at the companies that we've invested in the space, WorldCoin, Jensen, Giza Tech, et cetera, they all come with founders who, not everyone has a PhD in AI, but they at least have real production experience in that world. And they're recognizing that like the Web3 primitives are adding something to the product. my view is that these, all the companies and products that we're building here, they should not be sold to Web3. They should be sold to Web2. And we should show that by adding Web3, we're creating products that work better. And if we're not achieving that, then like, what are we doing?
Yeah, what I would say is that, to my point, that right now there's not a lot of demonstrated advantage to putting this stuff onto a blockchain, and so the advantage has to be somewhere in the future, right? You're sort of telling a story about how you can ride down the cost curve, or how you can find cheaper compute and aggregate it, or how something eventually happens that we're not seeing yet today. And so on that sense, the two things that I most look for in an AI founder, one is that they have to have very long time horizons. If you are kind of too narrowly focused on the right now, or what exactly you can do with what's in front of you, then I think the problems you're going to be trying to solve are kind of too narrow. And the reality is that AI is moving really fast, and you kind of can't be thinking about how can I use the things that are right in front of me to make something that I can use next week, because next week is going to get obsoleted really, really fast if you're a startup. The second thing is that I think in a way the term AI is kind of an anti-pattern. Like, I sort of would rather hear somebody say ML or neural nets or something like more specific. The more that I hear people saying the word AI, and of course, I mean, everybody probably in this room understands AI encompasses a lot of things, from a linear regression to somebody building a large language model. And papering over all of that, I think, one, it causes you to maybe lose sight of what is the specific problem that you're trying to solve, and what are the tools with which you're trying to solve it. So obviously there's nothing wrong with the word AI, but it tends to be correlated with people having an exactness about how exactly they're going to go about building something useful.
So that would be a red flag for you if someone came to you with
not a red flag, but like an orange flag, let's say, orange flag.
All right. Davi, you want to take the same question? I mean, how do you find alpha when
So I think like one key trait, so I'm looking for like AI crypto founder or just like AI founder working in crypto, is like, so they really need to know how to arbitrage. So like crypto by nature is like an arbitrage game. Like, what is that? So what is like DeFi? Like DeFi is regulation arbitrage, right? And then so when it comes to AI, so like one really just like emerging use case, or like something pretty burning right now is like ChatGPT is actually not accessible in China, in Abu Dhabi, in like Dubai, right? And then so like imagine if like someone can be like a local influence, and then so deploy like all the open source model, and then just like have like an alternative distribution channel out there, and then so like which can enable like the Chinese citizen and like the Dubai citizen like actually have access to LLM. And then I think like that's like a huge value proposition, right? Because like crypto is always good for arbitrage, and then just like how to circumvent, so just like how to circumvent like censorship, and then just like how to make accessibility better. So I think like that's one of the, that's one of my mental models out there when I looking for founder. And then so which means that like the founder probably not going to be a traditional B2B AI founder, because they will really pigeonhole in that B2B like sales world. And so it has to be very global. It has to be like a Ripple, right? It's like a Ripple global, and then like also know how to like arbitrage this game. Yeah.
Jake, you mentioned decentralized training. Can you maybe unpack that a little bit as a sort of something maybe people aren't considering at the moment?
The consensus on decentralized training, if you ask most people today, is that it is like not a problem worth working on. It's too slow. It's not feasible. It's impossible. Google has already won, etc. Like the compute has already been aggregated. I think a lot of that view comes from the sort of current state of how models have evolved to be trained, which is like in very close lockstep with like the hardware that has been provided for this purpose, and then the models sort of making use of the hardware. And I think what happens if you take a step back and you kind of ask yourself like, hey, if I have a, this sort of open network of heterogeneous commodity hardware of different kinds of GPUs, right? Like, how might I train a large, intelligent neural network on such a topology? I think what comes out of that is actually that we're pretty far along in understanding that from a research perspective. And so there hasn't been a lot of time that has been devoted to that problem. But I think some people are devoting that time now. And I think that consensus will change. And what I think is really, really interesting about these types of networks is that if we actually want to compete with large players like OpenAI and Google, and Meta and Microsoft, et cetera, who have aggregated a lot of compute, we need to create decentralized networks that can aggregate more compute. We know that's possible. Bitcoin is the biggest supercomputer in the world, but that problem has not been ultimately solved for AI training. So I'm sort of, my view is a little bit contrarian to the consensus, but I do think that we will develop very interesting algorithms for decentralized training in the next few years, and I think that will open up a lot of democratization of that part of the pipeline.
Zip, what do you think about that? Decentralized training, competing with OpenAI, etc.
Yeah, I'm unfortunately I have to be one of the general consensus that Jake is arguing against. I think the reality is that when you're a startup, well, let me reverse it actually. If you're a big company, there's a concept that I kind of loosely have in venture called upstream companies and downstream companies. And an upstream company is a company that's basically fighting against the current that the world is sending towards it, right? So for example, Airbnb was an upstream company. At the time, nobody wanted to go live in some random person's closet, right? That's just really weird. It's a weird thing to start getting people to normalize. But sometimes upstream companies can work. Right? Sometimes it does happen to be the case that the idea of staying in somebody's spare apartment really does take over the world and totally shift the cultural norms in society. But vast majority of companies don't do that. Vast majority of companies that are upstream companies fail almost immediately and they just die and waste all their money. Most companies that succeed are downstream companies, which is that they're following the current of what the world wants from them and the product is being pulled out of the demand that the world is exerting on the startup. And if you look in crypto, in AI generally, going into training is the most upstream you can possibly get. It is extremely capital intensive. Almost all the money is being made by a very small number of companies, and it's very specialized, centralized. It's not happening over network. It's not happening over internet connections. It's happening over fiber optic cables in in data centers that are very specialized over this particular task. So I think betting that everything is going to change about the way that we do training and the kind of spend that is concentrated in these very large training runs, it's possible that world changes, but it's a very tough bet to make with a startup and a very tough bet to make with investor money.
So probably I would just take a middle ground here because I think there's a spectrum of models, right? We have SLM, we have LLM, and we have MLM, right? So depending on the size of the model and depending on how many tokens you have out there. So so I've been actually trying to work with a founder friend of mine, and then so I'm training my own AI avatar by myself locally. So the application there is okay. So that can be a little bit dystopian because so I actually hope myself to live forever in the web. So once I pass away, and then so my grandkids can actually talk with my AI avatar, right? So that's a very interesting experiment. So I'm currently working with one of my geek founders out there, and then also going forward so that is not an LLM. So that's just a small LLM, right? So we don't need that much training data. So it's just all my digital footprints, then all my Telegram chats and all my WeChat chats out there, and then so I think there will be a scenario that the training itself, depending on a certain use cases or vertical, and then so can be done by decentralized way and locally. So but when it comes to LLM, and I think that's definitely hard, because you need a very strong economic of scale to do that, and then also LLM gonna become a public goods anyway. Just imagine Apache HTTP so all the and all the open source web server model out there and Kubernetes from Google, and I think all these things and then these standardized models out there gonna become a public goods. So public goods should come from corporates, and then should come from enterprises. Yeah, so that is my mental model of this spectrum.
Well, the other thing we're learning is that fine tuning is a little bit of a trap, and that more and more what people are learning is that in context learning is just way better than fine tuning on most tasks. And so I think we're going to see the amount of spend on fine tuning just collapse over the next 5 years.
Great. We have to wrap things up. So thanks very much, Haseeb, Dovi, Jake. Thanks very much.
Thank you.
Thank
you, everybody.
All right, we're going to transition now to our Innovators Showcase, and these are short 2.5-minute presentations from early stage innovators in this space. So we have a group of them and they're lined up over here. We're going to have them take the stage one after another, and then there will be a Q&A session at the end in case the audience would like to ask them questions on what they presented. Our MC for this portion of the programming is Jeff Wilser, who has a podcast called AI Curious. So please join me in welcoming Jeff Wilser to the stage.
Thank you so much. Hello, my name is Jeff Wilser. I am the host of the podcast AI Curious. And I am honored to be your moderator and host for the Innovators Showcase. We have an absolute murderer's row of brilliant minds in the AI space, and we are going to keep this very fast-paced, very fun, very spicy. Think of these as almost mini or even micro TED Talks, kind of doling out nuggets, and you get to ask them questions about how the magic is happening. Given time constraints, I will keep my intros very brief, even laconic, even a bit rude, so you hear less from me and more from them. We want that. So with all that, let's jump right in. First up is Jasper Zhang, the co-founder and CEO of Hyperbolic Labs. Jasper.
Hey everyone, mic check, can you hear me? Yeah, so I'm Jasper, I'm the CEO and co-founder of Hyperbolic. Today I'm going to present Hyperbolic, which is a decentralized AI cloud. Just a small background of myself. I graduated from Berkeley, I completed my math PhD in 2 years, later on work at Citadel Securities and Avalabs, and I have a co-founder, Yuchen, who graduated from University of Washington as an AI system PhD. The mission of Hyperbolic is we're going to democratize AI. We want to bring open access to AI, and ultimately we want to build an open ecosystem and economy for AI. We're solving 3 major problems. First, we're building a decentralized orchestration layer to aggregate decentralized heterogeneous compute, and we're building AI services to maximize the performance of different kinds of GPUs like AMD chips and NVIDIA chips. And I've just quickly skimmed through the architecture. And then the second goal is we're trying to build, ensure that we have security and verifiability in decentralized AI. And we partner with Berkeley researchers as well as Columbia researchers to invent a new verification mechanism called proof of sampling to make sure that the result is correctly verified, even it's run by a random node in the network. And lastly, you're working on the decentralized privacy path. So here's the ecosystem architecture we're building. We will have the decentralized orchestration layer to aggregate global GPUs. And on top, we'll build decentralized AI services that maximize the performance of different kinds of GPUs. And we also invite developers to come and build other services like training and fine-tuning services. On the right-hand side, we have the verification layer to make sure that the result is correct, and we have privacy layer. And then by having all these different layers, we envision an open collaborative AI ecosystem that different developers can just come and build different applications they want, and they can monetize, benefit from blockchains. So I'll just stop here, and thanks for your time.
Thank you, Jasper. Next up, Jonathan Jaranilla, CIO of Exabits.
Hey guys, I'm Jonathan of Exabits, and we are democratizing the economy of compute. So this quick talk is going to tell you about where we are and where we're going for the economy of compute. So as you know, the constraints in compute right now is so not necessarily feasible right now. So A16Z highlighted that with this quote and their study right here. So the real issue that a bunch of decentralized players like us, Hyperbolic, Akash, Edge Matrix, is really against the larger incumbents. So what we are building is sort of a different mechanism that allows a bunch of T3, T4 data centers to contribute to the inefficiencies that we see in this market. So things that we are building is multi-tenant resource management, automatic resource management, GPU acceleration. That's one of our key highlights that we want to bring to the market. And another thing is elastic training, really breaking down high compute models into more efficient GPU workloads so that a bunch of GPUs can work simultaneously to complete a task much more efficiently. So our background is that we've built over 100 data centers in the past, and we are leveraging these data centers and these clusters to provide more efficient GPUs to the network. So as far as the 100 data centers, we have over 65,000 GPUs ready to deploy into the network. That constitutes about 2 billion compute hours. And we are also partnered with some of the top tier hardware infrastructure providers, AMD, NVIDIA, partnered with also some of our suppliers, Foundry and Render Network. So our technology, what has it provided to the market? So it provides about a 72% savings. One of our customers usually used to pay $150,000 at AWS. Now they're paying $43,000, and also training speed. So our technology has allowed companies that work with us to increase their training speed. So it's a double-edged sword on savings and time. We are built a distribution network. So our supply is actually used by some of these partners of ours, Hyperbolic being one of them, IONET, Edge Matrix, Akash, and Aether. Next, so the most important thing is after proving out that we can do what we say we are doing in the market, it's now to sort of decentralize and democratize the access for the compute economy, allowing more people to participate and contribute and gain insights, and also sort of contribute and earn from the economy of compute. Thank you.
That was awesome. Thank you, John. Thank you, Jonathan. As an aside, I think it's very cool to see actual use cases like this today. I think it's a great example of this is not just abstract. This is not just a hope and a prayer for the future. He is showing actual cost savings, and it's a message that isn't really getting out there as often as it could be, that we're already in a world where this is actually happening. That said, please welcome up David Aronchik, CEO of Expanso. David.
Thanks, everyone. There we are. Hi, I'm Dave Aronchik. I'm here to talk to you about Bacalhau, the platform for universal and reproducible compute. I like to start by just kind of defining terms. Universal and reproducible compute. Basically, this means universal runs everywhere. So every type of device, every type of machine, every type of platform. And reproducible means runs the same, which is something that we really get lost. Now, we've heard lots of conversations today about things like snarks, things like verifiable compute and things like that. But I would argue there's something even more basic than that, something in between, just running a container and something that is cryptographically verifiable, which allows people to move compute jobs to various locations and be very specific about what runs. Myself, like I said, I co-founded the Bacalhau project. I've had a lot of experience both in the hyperscale Web 2 world as well as the cloud native world. But most recently, I worked at Protocol Labs working on things around compute over data for the Filecoin and IPFAS ecosystems. One of the reasons that I got going here was because I started my work actually at the NIH, where downloading data, accessing data as you would roll it out was often looked something like this. But nothing's changed from that. And even though it does work, it is not secure, it is not reliable, you don't really know what's going on here. And the problem is this, fundamentally, that our data is too big to move. And once you move it, it becomes non-reproducible, non-verifiable, and things like that. And with 175 zettabytes of data, you're talking about literally centuries to move things. How do we address it? with a compute over data platform, where you are moving your compute jobs to where it is, that is supports both Web 2 and Web 3. And that's the Berkeley RDI project that we launched 2 years ago. It is built to be open source. It's built to be multi-cloud. It supports things like Web 3. It's made for non-data centers. It runs on-prem, runs on drones, runs wherever you like. And most of all, it allows for this respecting data gravity and detailed execution, as well as isolation. And so whether or not it's very simple jobs all the way up to full AI training jobs or inference, you can do all of the above. It's very, very straightforward. It's already in use in places like the US Navy, the US Air Force, and things like that. And it is, like I said, open source as a community. The company is Expanso, but the project is open source, and we would love folks to come by and use it. We already support Web 2 and Web 3, and would love to have it support you as well.
Thanks, David. That was great. Thank you again. And please welcome Bidhan Roy, founder of Bagel.
Cool. Hi, everyone. So just as Spider-Man realized that his powers come with some obligations and responsibilities, we in the AI community are learning the same, that our innovations come with responsibilities. And that's what we're going to talk about today, how to build AI in a responsible way. So earlier this year, Anthropic, the creators of the chatbot Claude, had a major security breach. A lot of their users had their data leaked, and that included a lot of financial information, their account information, and it got exposed to a lot of unauthorized parties. And incidents like this will continue happening until we prioritize one thing, and that's privacy. And this is not a sentiment shared by a small amount of people. More than 57% of the consumers of AI systems are really worried about their privacy. They think AI poses a significant risk to their privacy. And if we cannot build AI in a privacy-preserving way, we'll never be able to scale. And that's one of the major problems we solve at Bagel. What Bagel is it's a cryptography and machine learning research lab. And we are taking the privacy-preserving machine learning space forward. And my name is Bidhan. I'm the founder of Bagel. I used to be the AI ML infra lead for Amazon Alexa, one of the biggest machine learning systems that exists on this planet. And now bringing my expertise to the decentralized AI space. And we believe for AI, the North Star is both decentralized and private. We need to bake privacy in at every step, from the data to the compute to the model building. Otherwise, it's not possible to scale. And we have looked into a bunch of tools that you can use to do the privacy in AI space. You guys have probably heard about ZKML. There's like homomorphic encryption. There's multi-party computation. There's federated learning. TEE, which is getting really popular nowadays. There's differential privacy. You can use all of these tools to be able to build privacy-preserving AI. And that's what we specialize in as well. So I'm not going to go into the details on how all of the technologies work here. These slides are from a different presentation. But you can go to our blog and learn about all of these technologies. We write our research in depth and share it with the community. We have also open sourced a bunch of fundamental research that we have uncovered ourselves. And you'd be able to read all of those and utilize all of these technologies that we share. So to conclude,
we are building an ecosystem where the community can come together and build massive scale AI models collaboratively, but we prioritize one thing than most, and that's privacy. This is my Twitter. If anyone is interested in asking me any questions, feel free to. Thank you.
Thank you, sir. Privacy is definitely a core theme of today, as is Spider-Man, Thanos, and wrestling. So I'm here for all of that. Next up, Xi Zhang, CEO and co-founder of ZetaBlock.
Hello. Hey, guys. This is Chi. I'm the co-founder and CEO of ZetaBlock. And apparently, based on this, you can see our mission is to unlock the massive AI adoption and potential with trustlessness. So a little bit about myself. I did my PhD from UC Berkeley a few years ago, focused on machine learning and causal inference. So at the moment, it's probably called responsible AI or explainable AI. And here is what we are trying to solve. Basically, we believe in the future, there's going to be a lot of models, billions of models built on top of a foundation model for multiple reasons. One is either like the foundation model doesn't have enough knowledge for you to solve those domain-specific questions or like tasks, or the model is just too big and it's too costly or too slow to handle some of the requirements. So that's why, based on that, with such a vast AI network, we believe in the future that AI needs to be trustless. And what trustless means here is mainly focused on two things. One is we need to have like the ownership and attribution of the, like a participant into the network or into this economy, have the appropriate incentive and appropriate provenance guarantee. And the second is actually how you can verify the entire process from end to end, apparently step by step, but to guarantee that in the future, there's a systematic way to track the traceability and auditability of the process. That is what we are talking about, this trust framework. And on top of that, what we see is a missing link for trustless AI is how we can really track the model during the building process. So fine-tuning is one of the probably like a building process we're talking about. A lot of times we're talking about distillation as well, how you can shrink the big model into smaller model to just focus on the tasks that you're requiring for. So that is what we consider in the future. That's the real starting point of a model new training process. And then if we look at that, what is the component that's super important for us to start tracking with is actually the data piece. Because as we know, like in the end, how you build a model is with the algorithm plus the data. And underlying you have a lot of GPU or like even CPU to use for building the process. So that's why based on that, our solution proposed here is a universal AI network that have like the 3 modules of data and model. And the blockchain piece is just for the provenance and the verifiability piece tracking. But underlying what you experience is very similar to how in Web2 you are building. Because again, this solution is not built for Web3 only. This solution is actually built for mainstream Web2 use cases and developers. So one is apparently you need a data infrastructure on top of below so that the developers can process the data correctly for like the downstream model building. And then how AI developer can actually submit the jobs again in a very similar to Web2 way. And then that process can be executed and the provenance and the verifiability will be later on tracked through the blockchain piece. So that's why, based on that, the ecosystem we're trying to build is downstream that there's a lot of like contributors or participants into this AI economy, from data to compute to model providers. But on top of that, once the model is built, how can you actually collaborate with people who require the access to those models, no matter from Web2 or from Web3? And again, there's a lot of use cases we can potentially solve in the future, from financiering to like a privacy guarantee. And Web3, apparently there's a lot of use cases, but I would say that's probably a smaller TAM than Web2. That's it. Thank you so much.
Thank you, Chi. That growth of AI models chart is wild. And I don't think most folks are thinking enough about that. That's a really interesting insight. And next up, please welcome George Antonio, CTO and co-founder of Atoma Network.
All right, so I'm going to talk about Atoma Network, project that I co-founded together with Hisham Khan, and we are basically pioneering decentralized AI and building a future where internet and the web is intent-driven and transparent. All right, so what is our main goal? What are our main goals? So first of all, Atoma is orchestrating the future of decentralized AI. We provide infrastructure that shape the way we leverage AI systems at scale, and we are building a coordination layer for AI, similar to how Bitcoin back in the day harnessed global compute power for mining and financial transactions. We are establishing or aim to establish a foundation for a new era of trustworthy and accessible transformative AI solutions. So in order to achieve this, we need to go beyond blockchains, right? So blockchains are great for everything related to governance, putting incentives forth for reinforcement through human feedback, licensing, royalties, tokenomics, etc. But blockchains have fundamental limitations in terms of compute, right? And so what we want to decouple compute from the actual consensus layer of blockchains, and therefore scale compute to like AI pipelines. So Atoma unlocks heavy compute for blockchains, and we do this through Atoma's elastic verifiability. So depending on the application and the use case at hand, you can actually choose what type of like security guarantees your application requires, right? And so this is possible through our novel sampling consensus algorithm that combines things like consensus mechanisms, sampling nodes, and trusted execution environments. And you can go from like very cheap, low security guarantees up to very high, more expensive, high security applications. So you have like a small diagram on how Atoma works. So Atoma can process requests that come from blockchains or Web2 applications, and basically these requests are routed through nodes on the Atoma that have like high reputation, have like availability, etc. And these nodes can basically coordinate and like compute whatever is requested to. And once that response is generated, Atoma protocol actually gives you very high guarantees that the outputs have not been tampered in any possible way. So through Atoma, we are basically unlocking a wide range of use cases that we think will shape the future of the internet and the web as a whole. Some of these are related to personal AI assistance. So nowadays we have a big problem within the web space regarding like data interoperability and the fact that all your data is concentrated across many companies, they don't communicate between themselves. We have huge privacy issues as well. We are working on public knowledge bases, which we think of as public goods that can be used for enhancing research and innovation across many sectors in society. We have been looking into enhancing Web3 wallets through LLMs and AI to make it intent-driven. Again, like intent-driven applications beyond Web3 wallets, and this is a step that we have seen is more like common nowadays through like, for example, OpenAI. The way we interact with these systems is more like through prompting and whatnot. And another use case that we are extremely interested in is a verifiable content generation, where you can actually generate content through third parties and whatnot in a way that is verifiably proven that it was created by whoever claimed to have created it. And yeah, thank you very much. Really appreciate it.
Thank you, George. No, that it truly is interesting. And there's so many use cases you point out. And I'm really curious about how this project and how all of these projects will fit together, play together, snap together in a world where they kind of all are realize, what does it look like? what is that? Are they Lego pieces that snap together? Maybe something we can get into later on in the audience Q&A. So thank you again, George. And now please welcome Brent Holmesley, VP of Community at Alethea AI.
Testing. Hi, everyone. I'm Brent. I am, excuse me, got a cold. I'm also the VP of Marketing, so this will be the least technical talk that you hear today. Let me get this going. Okay. So Alethea AI was founded in 2019 by our CEO, Arif Khan. And we've been working at the intersection of generative AI and blockchain since then. So we see the generative AI revolution. We've seen it happen for a while. It's an abundance machine. People can create things very quickly, almost infinite amounts of things, right? Obviously, compute is the issue there. And then Web3 is a scarcity engine. So Web3 and blockchain provide the provenance that is needed for verifiability and ownership. And the AI protocol has been working the AI protocol works in between these. Excuse me, y'all. So our first product that we launched was an NFT. It was an INFT named Alice. INFT is an intelligent NFT that has AI embedded in it. Alice was trained on the Bitcoin white paper as well as Lewis Carroll's. Oh gosh, sorry, y'all. Alice is a very interesting character to talk to. We auctioned her off at Sotheby's for about $500,000. So more recently, we've been working on expressive AI agents with microeconomies. We, like most people here, believe that people will own multiple AI agents. And we see liquidity within these agents to be integral to them realizing their true potential. So agents who can not only have liquidity you have given them, but also earn for you based off of their labor. We believe this is called bot entrepreneurship, and we see a very large market for this, where agents that you have provided labor for, either to train for others to use, or for other agents to use to connect together and utilize. We see a great market for this. And in May, we published a paper called "Liquidity is All You Need." So this explores the transformative role of liquidity in empowering AI agents. It's actually a blueprint for a future where digital entities are not only autonomous, but capable of managing their economic activities. The conclusion of this paper is that liquidity is actually integral for agents to live autonomously on a decentralized network. And thank you.
Thank you, Brent. Great stuff. Next up, please welcome Ethan Chan, CEO of Allium. Ethan.
Hello. Where is this one? Need to figure out how to use this. All right. So I'm the founder and CEO of Allium, and today I'm going to talk about data. So just blockchain data. Blockchain data is, how does it relate to AI? I'm sure all of you heard the saying, garbage in, garbage out. So the focus of Allium and what we do today is just making sure that's accurate blockchain data that goes into the systems for people to train their models on, to build their systems on top of. So we are the easiest way to query blockchain data today. So I want to talk about some of these use cases on the AI space. You can see a lot of institutions are coming into the space. You can see UBS, Visa, Fidelity, Citibank, all these folks are starting to apply a lot of the all the benefits of crypto into the normal financial system today, and AI is going to play a huge part to that. So how Allium fits in, we provide the good data for them to de-risk all their decision-making processes today. And how do we do that? We have these data platform product here. And for example, take a very simple question. If you want to answer the historical balance of a wallet today, it can require 1,000 lines of SQL code, lots of infrastructure, lots of RPC nodes that no one wants to deal with. And right now, what we do here is that we have an AI assistant on top of our data that you can actually just write a query, say, hey, like, this is supposed to be a GIF, but like, hey, look, give me the latest balances or a certain wallet, and the AI spits out the code. It automatically gives you the answers straight away to make it very, very simple. And I'm sure all of you have also seen airdrops. So at Allium, we have helped a lot of big companies and protocols like Wormhole help with their Sybil detection and clustering. So they use our data to cluster all these different wallets together, identify botnets, and basically what is known as fraud detection in the Web2 space. So I think these are some of the companies that also leverage a lot of the data infrastructure on their different needs for building fraud models, financial reporting. And I think lastly, I just want to say that like for everybody in this conference, everybody is doing a lot of AI research, and our goal, we have worked with the Uniswap Foundation to provide this DEX analytics portal for any researcher to also access the data. So if any of you AI researchers that are fed up with munching your own data, just like come and like ping me. And yeah, so these are some of what the researchers are saying, and I think that's it. Thank you.
Thank you, Ethan. Appreciate that. And I believe Dante got delayed in a flight. Is there a chance Dante is in the crowd? Any Dantes? Is your chance? Okay, then finally, last but not least, please welcome up Yannick Strade, co-founder and CEO of Arcium.
So hi everyone, I'm Yannick, CEO and co-founder at Arcium, and it's our mission at Arcium to allow everything to become encrypted while at the same time allowing anything to be computed over that encrypted state. And in the context of artificial intelligence, that means providing the required technology and infrastructure to perform decentralized confidential AI. And so with Arcium, it's possible to run distributed confidential training and inference in a private yet highly efficient way. And the problem that we're solving with Arcium is that in the past, the technologies utilized for confidential machine learning have been very inefficient due to cryptographic overhead. And so we provide this permissionless, decentralized confidential computing network that utilizes secure multi-party computations under the hood. And those secure multi-party computations are the perfectly fitting technology for blockchain infrastructure because they require multiple peers to collaboratively compute a function without maliciously collaborating. And so in our case, we employ a zero trust setting. And that means that our protocols come with the so-called dishonest majority trust assumption, the lowest possible trust assumption you could have against a set of nodes running any computation. And we adapt that computation protocol with extended security with a board, which means that if a node in such a multi-party computation decides to not compute or maliciously share invalid values, this can be cryptographically identified, and by utilizing a staking and slashing mechanism on a blockchain, we are able to enforce guaranteed execution. And our system is fine-tuned for machine learning because we were able to achieve an increased numerical stability with above 10 decimal digits of precision by employing both modular lifting and truncation and an uniform approximation of the sigmoid function via Fourier series. And so what we are trying to achieve really boils down to allowing for isolated data silos to be used in a uniform way to gain new kinds of intelligence without ever having to share that data. The data always remains in the owner's hands. And yeah, thanks for your attention.
Thank you, sir. That was great. I'd like to welcome all the innovators back to the stage for 10 minutes of audience Q&A. So all of our innovators, if you will. And I'm actually going to exert some host privilege and ask the first question, and we can kind of kick things off. These are all fascinating projects. There's so many interesting use cases. I think if there's a layperson here, and obviously this is not a crowd of lay folks, you guys are deep in this, you're experts, and I deeply respect that. One thing I'm curious about though is there's a lot of the functions you're working on in a very high level have some similarity and overlap of decentralizing AI and building infrastructure that's privacy preserving and so on. So I'm wondering, in the future, is there a world where these all kind of work together? Is there coordination of these projects and the many other amazing projects we saw earlier today? Or are you guys quasi-competitor? Is these one win, others lose? How do you see the competitive versus cooperative landscape here? How do you grapple with that? Jump ball, any of you guys can take this.
Yeah, I'll go real quick. So first, we've always been collaborative in nature. So we're working with one of our partners here, Hyperbolic, and a whole bunch of other people we once thought of as competitors. But now for us, it's just how do you just increase the distribution of decentralized compute. So in the future, it's decentralized compute. And then people start building stacks on top of that that are really complementary to furthering that sort of ethos that we're really trying to push.
Anyone else?
Yeah. So one of the things we get by building on top of Web3 rails is composability, which you don't get in Web2. Like all of these different projects which are building on different parts of the stack, or maybe there are some overlap. The composability of Web3 makes it really easy for them to work together towards a common use case. It can be a common customer, it can be some just common technology. So I think even if there's some overlap, it's actually easier for all of these projects to work together because of the composability of Web3. And that's what I look forward to enabling.
That is reassuring. I love an answer. Okay, let's turn it over to the audience. Any questions? Yes, sir. Do we have an extra mic?
Cool. So it was great to see all these presentations and really inspiring stuff. So going a little bit non-technical, I'm wondering how, like any one of you can answer that, I guess, about go-to-market strategy. Are you thinking more like a Trojan horse approach where you say, okay, you could do this use case in Web2 also, it's just that with these tools, it can be much better or faster? Or is it more like, oh, this is a use case which is not possible at all, but now with this technology, we make it possible? Or any other insight you have in that direction?
I'll go ahead first. Yeah, I think to me, I think with Web2, compared to Web2, it's probably very hard in the beginning to compare it with in the performance and cost perspective. But I think the ethos of crypto is again about collaboration and open source. And on top of that, you can actually build a better economy around it. Because if you think about Hugging Face, there's over 800,000 models and 200,000 data sets that nobody got money from except being kind of like used for free. So to me, I think crypto in the very beginning probably can help people in that way, in like how to better monetize things. But later on, we can then talk about how we can potentially make the technology more performant, even than Web2.
Yes, sir. We have a question in the front row. Grab my mic here.
Great presentations, everyone. I'm curious, as you're kind of growing your companies and making your first few hires, as you're trying to snipe talent from the larger players, like the Googles of the world, what's been the most convincing argument that's worked for you to kind of get them to jump on, like the Web3 bandwagon, basically?
It's a great question. Love that.
Because we believe the future of AI is collaborative, and those candidates also believe in that. And like people believe open source, which means that you need to share the AI with everyone. And the closed source AI companies don't believe in that, and they want to join their army that they want to be.
Other audience questions? Yes, sir. In the back row, the white shirt.
Curious show of hands if any of you on stage are fundraising right now.
The most important question of the day, clearly.
It is important, right? Thank you.
Other questions? Yes, sir, in the pink shirt.
Sorry, this is for a question for the decentralized compute guys. How do you deal with like the bandwidth limitations of using like internet or trying to push large data sets through the pipes of the internet that weren't designed for it?
Yeah, I can start. So Hyperbolic is building decentralized AI cloud. And because of that, we're currently focusing more on AI inference and GPU rental. So for AI inference, you only need one single machine in just one data center. So that doesn't affect the latency. And then for GPU rental, we're currently building solutions for cluster rental. So that will respect the inter-machine communication, and that will allow people to use the cluster to do training.
Yeah, for us, so the narrative for decentralized compute is my computer, your computer, I'll contribute to like a large AI model, right? But we're anti that. We're really working with the large data centers that we help build. So it's really clustered networks of T3, T4 clusters of A100s or H100s, because we find that more useful, especially more sustainable, and more useful for enterprise companies, which we are really focused on. So there's a lot of companies trying to tackle that decentralized component of my computer, your computer, but I think that's a couple years into becoming actually feasible, right? Like I think Berkeley, with their research, they are probably the most advanced team that can make that a possibility, but I think it's years ahead.
So I spent a lot of time in ML prior to my current job. I'll take a spicy position. I don't think it's ever going to be possible. Like the nature of ring reduce and sharing data between nodes will never, for some small value of never, be possible to share, because the whole nature of it is to group all these things together and to share each epoch and batch and so on. And so that approach right there of having awareness of scheduling around clusters that have higher bandwidth is probably the only way that it's going to be possible. Now, that said, I also strongly think that like a single machine in 2, 5, 10 years time will be able to train, whatever, a 400 billion parameter model, right? So it kind of like will resolve itself. But I'll say the net is, to your question, with Bacalhau, with the open source project, the whole point was to build gravity data awareness as a scheduling construct. So you could say, hey, you know what? I know where this data is, schedule this job next to it. And then you kind of like take care of a bunch of problems. It doesn't solve the, grouping a bunch of things together for training purposes, but it certainly prevents you from having to push big data over pipes that it wasn't built for.
We have time for 1 or 2 more questions. Any other from the audience? Okay, I've got 2 myself. In the front row, go ahead.
Hi, I know at least one of you have talked about, the decision to go open source, at least on a part of your project. So like Expanso and then Bacalhau being the specific open source aspect to this. As you talk about how important it is to be collaborative in nature, how have you all thought about like your business models going forward? Have you thought about open sourcing any aspect of your project or any aspect of your infrastructure?
Yeah, I can go on this one. So yeah, definitely open sourcing, especially in this area is, I will say, is crucial for the sake of transparency and building communities around each project. I think collaboration is also kind of like the incentives are put forth for collaborating, as we were discussing. And one of the reasons that this can even be enhanced by decentralized networks is through like data interoperability and knowledge interoperability, right? Like in Web2 companies, like this data is siloed across like multiple companies and you don't have access to this, like different companies cannot share their data. Whereas like in decentralized networks is a much more like flexible and a way to like compose systems, and therefore there is a much more need for being very clear what you are building, how you are building it, what's the key innovations that you are building in. And I think open source interoperability are crucial ingredients into this. Yeah.
We are almost you have a quick response. Go for it.
Yeah, super brief. I mean, especially for what we're building, it's highly important and actually crucial to open source all of the technology, simply because this trustlessness that we promise on a cryptographic level can only be verified if everyone has access to the source code and can mathematically be convinced of all of those functions being implemented accordingly.
Thank you. We are almost out of time. I'm going to sneak in one last question. That's kind of a summative question for the day. Is it right to frame decentralized AI versus the open AIs of the world as a David versus Goliath struggle? Is that premise correct? If not, why? And if so, what's the best argument for David? What's the best argument why that slingshot might actually have a chance?
I think it boils down to use cases as well. And I think what we found really is that, especially when utilizing blockchains combined with, in our case, MPC to offer confidentiality, it's now possible to process data that was previously impossible to be processed. So highly sensitive patient data, for example. So we have an active project where we are collaborating on cancer research, and for these kinds of machine learning models, it's crucial and also from a regulatory standpoint enforced that this data is not shared. And with those trustless protocols, which are provided by decentralization, by using decentralized machine learning, it's now possible to get new intelligence that previously was impossible. So I think on a value side of things, decentralized AI can bring more to the table than centralized AI could.
Any final thought there before we let folks go enjoy the drinks?
Yeah, I will also add there, like, privacy is a huge motto as well. And decentralized networks, we have much more privacy-oriented approach to the problem, and I think we'll basically provide much better products in that term. There is also great value to be extracted at the margin, right? So for example, OpenAI, like ChatGPT, etc., these models are highly restricted in like what they can answer to you. And there is huge value to be unlocked when you basically allow more flexible models that maybe are tailored for specific communities, for specific countries that have not been catched up by ChatGPT and other models. And they will never be able to catch all these at margin use cases because of regulatory pressures and whatnot.
Thank you all. Please give it up for our innovators. That was great, guys. And we now have a few closing remarks from Don. Welcome back to the stage. Thank you.
Great. Yeah, thanks also for Jeff for the great moderation, MC, for this Innovator showcase. And I wanted to thank everyone for participating in this great summit. So in the summit, we really had a very broad coverage of different topics, including open source AI, and confidential compute, and other foundations for decentralized AI. And also we have a lot of practitioners in the field share their experience and lessons learned in decentralized AI, as well as great innovator showcase at the end, showcasing some of the great innovation happening in the real world in the space as well. So I want to thank everyone and for sharing this opportunity with us. Decentralized AI is a really important and emerging field. We hope that the community can get together, really build towards a future, as I mentioned in the morning, towards this open, responsible AI economy. So again, just as a reminder, so for people who are interested in learning more about large language model LLM agents, please, you can sign up on the class later on the course website. So if you go to RDI, rdi.berkeley.edu, go to the academic site, you will see the course link there. That's where you can find more information about the LLM agents. And also, as I mentioned, so we hope to actually build a great community together to build towards this future of open, responsible AI economy. So we hope everyone here can join, either to work together to address interesting research challenges, or as practitioner or as contributor to contribute to this great vision. So for that, so please do sign up to get more information at Open Responsible AI Economy, one word, .org. So again, Open Responsible AI Economy.org. With that, thanks everyone.
And we'll be sure to share those links that Dawn just mentioned with everybody who registered via the Luma. So I just want to thank our sponsors for today and invite you all to join us at the reception, where we have a demo going on by WorldCoin of their iris scanning orb. And we have a poster session and some light snacks for you. So please join us at the reception now between now and 6 p.m. Thank you very much.